So, it's all better. Yeah. Tell me, I have to get better camera because this is your ordinary vision sensor. Better quality of camera. Yeah, okay, no, Good morning. Welcome to FIRE 2024. This is the 16th edition of FIRE.
Sir.
Yes. So when we started FIRE, back in 2008, we never thought that we will manage to grow to this level. 2008 to 2024. It's a long journey. So it was only possible for you guys. I mean, the community helped us within the country and outside the country, largely. We were always very fortunate to have supports from people like Steve Robertson. Long back when this was conceived, this idea, there was one Karen Spark Jones who supported this idea. And then you see, I mean, the whole community was very much helpful. So there is a small history which I don't think that I need to repeat now. You can please Google us out and help us to grow further. Now we will start with our opening talk for this FIRE, Evaluating Search for Systematic Review Creation by Professor Alan Hunbury. Alan.
Okay, good morning, everybody. So I'm very happy to be here. And I'm talking about evaluating search for systematic review creation. This is work that was done with a PhD student of mine who has now finished, Wojciech Kuza. And yeah, so what I'm going to tell you is starting a little bit about me. And then for those of you who don't know what systematic reviews are, I'll tell you what they are. And then a bit about some of the work that we did on systematic reviews. And at the end, there should be some time to ask questions. So a bit about me. So that's the university that I come from. So that's the Technical University in Vienna in Austria. So this is the main old building. So about over 200 years old. And it's sort of expanded. So there are lots of buildings around there. But it's a purely engineering university with about 27,000 students. And yeah, but that's the university. A bit about me. So I'm talking about medical information retrieval. So this is something that I've been doing now for many years. So these are projects that I've been involved in starting in 2010, medical information analysis and search. So these were research projects that ran And what was interesting, also out of the first research project, there was a spin-off that came in 2016, which is still running. It's to support radiologists in analyzing the images. So you see the system automatically detects unusual patterns in lung CTs and shows the patterns to radiologists. So I'm not going to talk about this today, but feel happy to ask me about it. I'm happy to talk about it. But yeah, it's been really interesting to take this research and turn it into the system which is currently being used in hospitals in Europe. Something else. So this is now getting closer to what I'm talking about today. This was the Visceral project. And this project had to do with the evaluation of segmentation of organs on whole body CTs. And so basically what you see here is the ground truth. So this is essentially a whole body scan, of a CT scan. And then this is where radiologists or experts have gone and drawn in the areas of the various organs, with the idea being that this was pretty much organized as a challenge, same way that the fire tracks are organized, that groups that did automatic segmentation had to do the segmentation and then it got evaluated. Now, the problem with this was that people working in information retrieval are absolutely obsessed with evaluation. At that stage, people working in medical image analysis didn't care about evaluation really so much. So the first problem we had to solve with this was actually, what are the best measures to use for that evaluation? And so together with a PhD student then, Aziz Taha, we evaluated all the measures that were used. It was a complete mess. People were using, for different papers, different measures. It wasn't comparable. So we wrote a paper about measures. We provided a tool, and we submitted the paper to the best medical imaging journal, and back came, no, sorry, this is not interesting. I think it was a desk reject. The editor said, this is not interesting for medical imaging. They don't, this is. So then we submitted it to the lower ranked medical imaging journal, and they accepted it. And this is just to show you, you should never believe the editors, because this paper currently has 2,591 citations. So it really was interesting. The editor just didn't know it. So this is not to brag, but this is just sort of unexpected that just looking at evaluation actually made such an impact on the medical imaging community. This is also a nice demonstration where we took a lot of what we'd learned from the information retrieval community and moved it over to the medical imaging community, and that made an impact there. As I say, we're getting closer to what I'm talking about today. One of the things that came out of this study was that there are many things that can really change when you change small things in evaluation. So this is still sticking with the medical imaging. And we looked, for example, at what happens if you have different radiologists creating the ground truth for the positions of the organs. Because of course, then we had the people taking part who would do the automatic segmentation of the organs. And of course, we had to compare it to the ground truth. And we did an example, for example, with two different annotators, both expert radiologists. And when we took the ground truth from annotator 1, and we had 10 submissions, and then we basically calculated the metrics and we ranked the submissions according to how close they were to the ground truth, we got that order. Then we asked a second radiologist to create the ground truth, and that was the annotator 2. And then we ranked the submissions according to the ground truth created by that annotator. And that's what came out. So really, it was clear that submission number 3 was the worst for both annotators, so that stayed at the bottom. But the one that was second worst for annotator 1 moved up to first position for annotator number 2. So yeah, that's just showing you the, you might say, well, how can radiologists make such a bad job of doing this? Obviously, but even they sometimes have trouble knowing where to stop. So is this still part of the liver or is it not part of the liver? So, and there are even smaller things that can change. So if we did a ranking with the Hausdorff distance, then we would get that. If we changed it slightly and used the Hausdorff distance 95, which just gets rid of some of the outliers, then we suddenly found that the one that was ranked worst with the Hausdorff distance was ranked top with the Hausdorff distance 95. So just a slight change to the metric, and already, the worst becomes the best. Or aggregating the results, but with the mean. So of course you do this over many images, and then you aggregate the results with the mean. What if we aggregated with the median? Again, huge differences. So what you decide to choose when you are doing this evaluation can make a huge difference to the final ranking that comes out. So think about that later when you're looking at the rankings of the FHIR submissions. Although, of course, being information retrieval people, we have taken a lot of care about this, I'm sure. So the final thing, so this was a project that ran until this year, the Dossier project, which had to do with domain-specific search. So essentially, we got 15 PhD students from around the world, and they did their PhD on different topics related to that for 3 years. And you can see Wojciech at the back there. So that's his work mostly that I was talking about today. And the sort of search that we worked on in this project was what's referred to as professional search. And by professional search, we essentially mean search that somebody is paid to do. So it's part of their job. So they go to work and they're paid money and they have a task which involves search, which they have to do. And of course, because they're being paid for it, there are various constraints like budget and time that they constrain what they're allowed to do. And the type of professional search I'm talking about today is search for creating systematic reviews in the medical domain. And systematic reviews form the basis of what's called evidence-based medicine, which is quite amazing that this exists because you would hope that all medicine would be based on evidence, but there is a specific area called evidence-based medicine. It basically means that you look what works before you apply it. And so they have created this sort of pyramid showing the quality of evidence for different types of medical publication. And I'm not going to go through all of them, but one of the important ones that I'm mentioning here, the randomized controlled trials. And essentially, this is the gold standard of a study that can be done to evaluate if a medical intervention works, where an intervention could be a new drug or a new surgery or something like that. So what happens for a randomized controlled trial is essentially the participants in the trial are randomly divided into a control group and an intervention group. So this randomly is important. You see it's even in the title of randomized controlled trial. And the people in the control group don't get the intervention. The people in the intervention group do get the intervention. Of course, they all have to believe that they're getting the intervention. So if it's a medication, some sort of pill, for example, the people in the control group will get a placebo, which is essentially a sugar pill, which looks exactly the same as the pill that the real pill. So everybody believes that they're getting the medication. And then afterwards, they see if the medication works or not. So they measure the difference between the people who believed they were getting the medication but were not getting it, and the people who believed they were getting the medication and were getting it. And then you can look at things like, did people live longer? Was the pain reduced? Was quality of life improved? to see if the intervention works or not. So there are many systematic reviews that are done. I'll show you, many randomized controlled trials that are done. And the problem is that, yeah, there are many of them that are done for the same medication. So in order to sort of get a view of what the current status is for a certain intervention, the systematic review is done. And essentially what the systematic review does is it searches through all of the literature on randomized controlled trials to find all of the papers about a certain intervention, and then brings all of that information together so that you have an overview about whether the intervention works or not. And the problem with systematic review, so of course it makes sense to do it. The problem is it's pretty much today all done manually. So you see, on average, a systematic review can take 67 weeks, so over a year, to actually find out if, according to current science, an intervention works or not, which is a long time. Of course, because it's manually done, there could be human error. There's a problem because there's more and more publications being done, so there are more and more papers to look through. Of course, you have to find all of the relevant papers because you don't want to ignore some experiments that people did, so that's why it's necessary to find all of them. It was a big challenge when the pandemic came because they wanted, very quickly to know, so what interventions work? And then, well, the systematic review people say, well, we can tell you in a year. But yeah, it has to happen very quickly. And so because of this, there's been a lot of work on automating various aspects of the systematic reviews. I'll show you an example so that we know what we're talking about, exactly what a systematic review looks like. So there's an organization called Cochrane, and they do systematic reviews, they coordinate them. And when a systematic review is done, there are a number of steps. So it's a protocol that's been defined, it's very strictly adhered to make sure that no mistakes are made. And the first thing that has to be done before you even do the systematic review is you have to publish what's called the systematic review protocol. This is essentially a description of how you're going to do the systematic review. So this gets published. So here, for example, it's a protocol on tramadol for neuropathic pain. You see this was published 5th of April, 2002. That's important for later, but that's when the protocol was published. And then it says here, so what types of participants are they going to look at, what types of outcome measures, what search methods are they going to use. So it's all defined. The reason for this is so that afterwards you can't do something else and then say, oh, well, we changed our mind. It's all been published. So once this is published, you have to follow what you said you were going to do. Then there are also other things that come out. So this is, for example, the PICO terms. This is tells you the population. So this is the group that the intervention is used on, what the intervention is. So in this case, it's just one medication, tramadol. What is compared to, so here placebo, so sugar pill, and what outcomes they're going to look at. So for example, it's a pain medication. They're going to look at pain relief, adverse events, if people die from taking it. So that's what they're going to examine. They do Boolean search. So they also publish the search query that they're going to use. This is also in the protocol. And so they have to use that particular Boolean search query. You see, it's quite a complex query, but that's what they're going to search, or how they're going to search. This is the pipeline. So of course, the reason that they do Boolean search is they want to get all possible or all relevant results. And then after that, they have people look at the papers that were returned and decide whether they're relevant or not. Because the problem with just using a Boolean search to get all relevant results is you get really lots of results that are also not relevant. So for this example, you see they started off with 1,277 papers, essentially. And then after having people look at the papers, they found that only 6 of those were actually relevant. So the search gave you 1,277 papers, and after a lot of reading and examination of the papers, you end up finding out that only 6 are actually relevant. And what comes out at the end is this, what's called a meta-analysis. So you see it's a standardized table that's printed. You have the different papers over there. You have different weights and so on. Here, for every paper, they say, for example, here on this side, if tramadol is favored in the randomized controlled trial, or if the placebo is favored. And so, of course, if it's on this side, it means that the intervention works. And then they do this diamond thing over here, which is sort of, overall value for this. So overall, this intervention works. They also have this bit called risk of bias, because sometimes people don't do the randomized controlled trials exactly as they should. So there could be, for example, errors in the randomization, where people somehow sort of find out if they're getting the placebo or not. So then they try and find out if there is some risk of bias. Okay, so that's what comes out of the systematic review. And you can see now why it sometimes takes a year or more, because reading through all of these papers and doing this analysis takes time. And that's what comes out. So that, of course, that's the final review. I've highlighted the date over there, 19th of April, 2004. Remember that the protocol was published in 2002, so this took about 2 years to create this. And you might say, okay, well, this is the final review. But it's not, because more papers get published. So then a few years later, they looked at it again. So in 2004, they updated the review and published a new version. 2006, they did it again. 2017, they did it again. You might think, well, this doesn't make any difference. Why go to this trouble if you know it works or not? But if you look at the conclusions, you see in 2004, they said, well, tramadol is an effective treatment for neuropathic pain. In 2006, they said tramadol is an effective treatment for neuropathic pain. And in 2017, it changed. There were some more studies, and the outcome was there is only modest information about the use of tramadol in neuropathic pain coming from small, largely inadequate studies with potential risk of bias. So after all of those years, the final outcome is, well, actually, we don't know. So this shows you some of the challenges with doing systematic reviews, because you'd think, well, there are more studies that have been done in the meantime. The result should be somehow stronger, but the additional studies have made the result, somehow weaker. So now the current state is we don't know if it works or not. So that's the current state of the art, you would say, for this particular intervention. So I hope with that I've given you sort of an idea why this is complex and why it takes so much time. The part that really takes a lot of time, as you can imagine, is finding exactly the correct studies to include in the systematic review. Because remember, this is the part that involves a Boolean search and then reading through a lot of papers by experts. And this is what's also called citation screening. So to show you another example of why this takes a long time, for this particular systematic review, so of course, you searching in some databases like PubMed, which have about 30 million papers in them. For this particular systematic review, the Boolean search gave you 2,072 papers. Then the first stage is you have the experts look at the title and abstracts. And after they've looked at the title and abstracts and decide whether it's relevant or not, they end up with 302 papers. And for those 302 papers, again, the experts look no longer just at title and abstract, but they look at the full text. And after looking at the full text of 302 papers, so reading through the text and deciding whether it's relevant or not, they end up with 42 papers that are relevant. So 2% of the original papers are, after this long process, considered relevant, and they are then used for data extraction, meta-analysis to produce this table. So again, an illustration of why it makes sense to be able to automate this as much as possible. So, of course, because this is such a big problem, there's been a lot of work that's been done on automated citation screening. So already starting in 2006, there was the first paper published, which used various methods. The sort of idea that people have been doing with citation screening is, well, you're not going to get rid of the experts completely. So the idea was, you have this citation list of 2,000 papers that you have to look through. Let's split it in two. So you say, for example, 1,000 papers go to the experts, and the experts label them as relevant or not relevant. And then they use that to train some sort of supervised classifier, which then will look at the other 50% and say whether they're relevant or not. So essentially, the idea is you can reduce the work of experts by half, but you can't train a general classifier because for each systematic review, it's different, whether the paper is relevant or not. So yeah, I mean, it's reducing the work by half. It doesn't sound that great, but yeah, there's been a lot of work that's done on that. And of course, as is usual, you can find, I've just given you papers that you can look at there. They've tried all potential classification methods on that, with the latest one, of course, using LLMs for making the decision. So you can, there's a lot of work done on that. And there are also some commercial products that do it. So this is sort of slowly moving into use. This is also not only done in medicine. So seen more broadly, the systematic reviews are referred to as technologically assisted reviews. And they're also used, for example, in the legal domain, because there it's important to be able to search through past court cases. They're also used, for example, in software engineering. So there's a big movement in software engineering to do these sort of reviews so that you really know what software engineering interventions, let's say, or approaches work and which don't. So they're very, wide applications for these types of reviews. Now, very briefly, because you, of course, all know about this, information retrieval evaluation. If you want to do information retrieval evaluation, you need a set of documents, you need the queries, you need the relevance judgments, and you need the measures. Then you put them together like this. You put the documents into the search engine, put the queries into the search engine, look at the results, compare them to the relevance judgments, and you decide which is best based on the measures. So that's not new for you, just a reminder. What I'm now going to look at is this measures part over here. Because the question is, again, there's so many ways of automating these systematic reviews. How do we measure which is the best? And I'm going to show you two aspects of that. The first one is, which evaluation measure do you use to decide which approach is best? So the typical information retrieval evaluation measure. Now, for systematic review automation, back in 2006, they introduced a specific measure. This is called the work saved over sampling at R% recall. That's how it's defined. And ever since that was introduced in 2006, people have used it. So every paper that is published based on that for automation of systematic reviews will give them results for the measure work saved over sampling. But then we were saying, well, hang on, does that measure actually make sense? What does it measure? Does it make sense to decide based on that? So we started investigating it. Before I show you what we came to, I'll just give you an idea of how it works. So, that's not so straightforward to see. I'll give you an example now how to calculate it. So let's say you have 1,000 documents. So these are the 1,000 documents that came out of the Boolean search, and now people have to decide whether they're relevant or not. But now we just go to the Boolean search, or we go to some search, ranked search, and so some sort of black box ranked search over there. And the top document that comes out of the ranked search, has some doc ID, and according to the algorithm is very relevant. And the correct label, because we also have the correct label, whether these systematic review, randomized controlled trials are relevant for the systematic review or not, is include. So that one is good because it's relevant and it's highly ranked. The one ranked second is also an include. The one ranked third is an include. The one ranked fourth is the first one, which actually is not relevant for the systematic review. So it's actually an exclude. And so you can keep going through. Here we're down to 656. And so, of course, you'd hope that as you go further down the ranked list, the number of excludes would get higher. That would indication that the algorithm is working correctly. Now, what does the work saved over sampling do? It's usually done work saved over sampling at 95%. So what the 95% says is you go down the list until you achieve 95% recall, and then you create a stop line over there. And you say that above this line, you have the true positives and false positives. And below this line, the false negatives and true negatives. So because you only consider the documents that were found above this cutoff. And so given that, you can put these values into the equation, true negatives and false negatives. N is the total number of documents. The R is 95%, so 1 minus R is 0.05. And so you get the value for the WSS. And essentially, what the WSS is saying is it's the time saved if you exclude those documents over there. So if the reviewer only has to look up to the 95% recall level. And how bad, how much do you miss if you exclude after that? And of course, if the line gets moved higher, this cutoff, then your WSS is higher. If it gets moved this way, the WSS is lower. So one of the things we found out that was quite strange about the WSS is that its values depended on the number of relevant documents. So here, a WSS is this dark blue line. And this is an animation, so you see over here, it's set to 95%. If there are 5% relevant documents, the blue line is like that. If you increase to sort of 52% relevant documents, the slope changes. And as you increase the number of relevant documents, the slope changes again. So this means that you can't compare the WSS between different data sets because it depends on the number of relevant documents in the data set. So already that's a pretty bad thing for a measure to have. You can't compare across different data sets. There are also other things. For example, You look over here, the numerator is a sum of the true negative and false negatives. But of course, the true negatives is something that should be maximized, and the false negatives is something that should be minimized. So, if you're trying to optimize something which is a sum of something that should be maximized and a sum of something that should be minimized, you're sort of going in the wrong way. And, some other things also, like there's this constant over here, because this is always 0.05 or whatever, based on what R is chosen at. So why are you subtracting a constant? So in the end, we were saying, well, actually, even though this has been used for almost 20 years, it doesn't make sense. So we did something about it. And essentially, we had to go at normalizing it. So we said, well, there would be a minimum value of the WSS. And the minimum value of the WSS, this would be the worst case possible, of course, wouldn't occur in practice. That would, if all of the exclude documents are ranked first, so you put all the excludes first and the includes after them, then you should get them, or you will get the minimum value for the WSS. And of course, the maximum value would be if you put all the include documents, all the relevant ones at the top, followed by the irrelevant ones, and then you get the maximum value. For those you can calculate. And so we normalized it by basically, taking the maximum value minus the minimum value and subtracting the minimum value from the actual WSS value. And we did some calculation of that. And it turns out, I'm not going to show you everything. It's about one column of calculations. If you work through that, you end up that the normalized WSS is the true negative divided by the true negative plus false positive, which is the true negative rate. And the true negative rate, of course, is something that exists, and it doesn't suffer from all of these problems with the WSS. So the WSS was just some sort of weird formulation of the true negative rate. Then we say, well, why didn't you use the true negative rate? It doesn't have these weird things. And so, yeah, that's what came out of this. A better way of measuring whether an approach for citation screening is good or not would be to use the true negative rate. Now I'm going to look at a different aspect that we were doing. Because the typical way of doing this evaluation is to say that every document has an equal weight. So every document is equally valid. With systematic reviews, it's not necessarily so. Because there are various outcomes, and every paper has a number of outcomes. So essentially, an outcome could be something like mortality or morbidity. So do the people die from taking the intervention, or do they stay ill? Do they get better? There are things like quality of life, cost effectiveness, and different papers have different outcomes, but they also have different weights in the final review. So remember, if we look at this over here, you'll see that those are 5 studies, or 5 different papers, essentially. You have these different outcome values. So either it favors the control or it favors the intervention and the actual outcome. But there are also these weights. So because study A was most probably the largest study, it has the highest weight. So it has the highest effect on this actual final outcome over here. So all the papers that are taken into the systematic review do not have an equal contribution. It's even in this table. Study A over here has the highest contribution to this systematic review outcome. So if your information retrieval process were to miss study A, it would be a disaster because your systematic review would be completely off. So you can see on a few examples over here. So this is the 100% recall. You find all 5 papers. here 20% recall, but you only find study A, and actually it makes no difference because study A has such a high weight because it's such a well-done study that even if you only find that and you don't find the other documents, it doesn't matter. But if, for example, here's recall 80%, so you're missing study C, it also doesn't matter so much. So the position of the diamonds changed a bit, but overall, the result is the same. But if you were only to find, for example, study B, then the result is completely different. So you can see that the different papers have different contributions to the final systematic review. So it doesn't make sense to do a typical information retrieval approach and say, well, every document has an equal contribution, because it's clear it doesn't. There's some that if you miss them, it completely changes the result of the systematic review. So we developed a framework that takes that into account. And essentially, the idea was we got access to the papers, we could extract the analyses from the papers, and then we could redo the analysis. And we could say, so if we leave out a certain paper, how much does it change the result of the systematic review? And so we did that. We did the recalculations of the systematic review outcomes by taking various percentages of various cutoffs. So we'd say, these are the ranked documents that come back. We cut off at a certain position, like 30% of the total, and then we see by how much does the systematic review outcome change. And by that, we can sort of measure the publication influence. So we defined a measure, but a very simple measure, which is the difference between the original outcome of the systematic review and the outcome after we've taken some cutoff. So after we've potentially excluded some of the papers. Of course, if this outcome is larger, it's essentially the difference in position of the diamond at the end, then leaving those papers out made a big change to the systematic review. If that value is small, then leaving those papers out, those papers didn't make a difference anyway, so it's not so bad if we missed them. And so there was a clay task on systematic reviews. And so we took, that's 2019. There were 17 reviews in the training set, 15 in the test set. And we looked at each outcome of the review. So you see the outcome per review in the training set, the minimum number of outcomes was 2, the maximum was 41, with a median of 9. And then, so we looked at each outcome. So remember, the outcome is something like, does the pain get reduced? Does the life last longer? Are there side effects? Things like that. And then we reevaluated that by taking different cutoffs and seeing if it changes the outcomes. And of course, it does. So we made a nice plot which shows you, so we essentially took the runs from the clay task in 2019. So those were the runs that were submitted. And back then, they were evaluated using MAP. Of course, MAP says every paper has exactly the same value. So this is the ranking that came out with MAP. Then we were looking at the outcomes and the differences in the outcomes here for this graph at a 30% cutoff. And this is the relative difference in the study outcome that you see over there. This is that showed you how different is the outcome based on the original. So of course, if it gets further to the right, it means there's a larger outcome. So you can see a lot of outliers over here. This only goes as far as 30, but in fact, the plot continues up to 100. So there's a lot of extra X's that go over here. And the orange points are the interesting things because they are the average values of these differences between original value and if we leave some of the papers out. And so a lower value of this is better. But what you see here is if you were to rank based on this new approach, the ranking of the runs would be completely different. So here they're ranked by MAP. The top ones would remain the same, but then you'd start getting, for example, here. So Sheffield would do much better if it was actually ranked by the paper impact like we do, than if we just assume that all of the papers have an equal contribution. So again, this is something that shows if you know something about the domain that you're working in, like the papers have different impact on the outcomes, we should take that into account because it can actually make a difference to which ones we believe are the techniques that work best. So up to now, this particular group has most probably thought, well, they don't have, their system didn't work so well, but actually it's, if you rank by this, it is one of the best performing systems. And with that, I'm getting to the conclusion. So the main thing to highlight is you learn a lot from talking to the experts in the area. And this was actually sort of like a bit of anthropology, because the systematic review people tended, when we started, to hold conferences that were by invitation only. So it wasn't really possible to get into the conferences where the experts and systematic reviews discussed with each other. And what Wojciech did is he managed, by talking to people, to get himself invited to these systematic review conferences. And with that, he could then start talking to the experts and find out all of these things. And it was quite nice because he said he went to the first conference and they were saying, well, here are the problems. And then a few years later, at the end of his PhD, he went to the conference again and he said, well, here are the solutions. So I don't know if they're going to accept these as the solutions, but we have to see. And, oh, there's one last thing. There's a data set. I didn't have time to talk about it, but there is a data set just published recently, and it consists of a lot of really nice systematic reviews that you can then also use for these sorts of analyses. And that's it. So thank you.
Any question? Yeah, thanks for introducing this. So just a curiosity level. So you said it WSS, which you kind of, that hypothetical line, which 95% where you have the true positives and false positives all up, and that's reducing the workload by the amount. So throwing, say, 2,000 documents to a pretend LLM with prompts, how comparable the job is being done as with the experts? Is there any study or something?
Giving to what, to the
say 2,000 documents I have in the entry level of the funnel. So it's a long funnel. You started to say 2,000 documents and reduce to 200 and then to 40. So these step downs, where mostly elimination is happening. So do you think, I mean, what is the state of the art pretend LLMs? Can they be of any help to
Yes. So, I mean, that was also one of the things we were looking at. So, well, I'm not going to go back now, but there was a list of papers and there was reference in LLM paper.
Yeah, one was there,
Yeah.
prompt-based learning and yeah.
We were also looking at LLMs, but there's also another problem that we came up with for the evaluation, and that is the LLMs have very likely seen the systematic reviews during the training. And so we had the problem that we weren't sure if we were using this evaluation thing, if it was because the LLMs were actually working or because the data, or the training data was, or the systematic reviews were in the training data. But also part of the dataset paper, we created a dataset which was consisted of systematic reviews after the cutoff deadline for the training for some of those earlier models. So we have a sort of data set that we were also using for evaluating using LLMs. But the LLMs are definitely useful. So you can do things, just again, the problem with evaluating them.
Yeah, so a corollary question here. So, I mean, pretend trillion parameter LLM versus much smaller LLMs, which can have a lot bias on this particular topic. So as it's true, as you said, that you need to keep updating this review, as a lot of paper will get published eventually. So whatever knowledge you gather in the first effort, can an LLM be trained like that, that it can automatically identify and keep doing this job on your behalf? I mean, this just
yeah, well, I think that would be the perfect thing that could happen. We need something that, because it's also quite amazing that these reviews are not automatically updated, and they should be, and I'm sure we have the technology to do it. But yeah, I think we could even do it. It's also a problem acceptance on the side of the practitioners.
Yeah.
If they will accept automatically updated.
So validation
reviews.
has to be, I mean, somehow incorporated in this.
Yeah. So we have to demonstrate. I mean, this is a lot of the effort that we were doing, because one of the things that we found out when Wojciech went to the first meeting is they don't know what works.
Right.
And so he was trying to take their concerns and put them into measures so that we could then go back to them and say, this is how you do it.
Thank you.
Thank you very much. This was a very plausible example with the 6 papers and the one that has a high impact. Now, of course, we can develop a metric that works well for that, but the question would be, how does it reflect well the overall, let's say, the numbers of statistics of reviews in terms of how many papers do they include typically in the final, and how is the distribution of the contribution? Is it possible to say, and could you derive from there the statistics that your work metric really works well on a large scale?
Well, I think it should. It's independent of how many papers, because if there are 2 papers that contribute, then they would have a big impact if they're excluded. So I don't think that makes that much difference. So the example was just with 1 paper that has a big impact, because that's easy in an example. But if they all have equal impact, then of course taking out any of them will, I think it's quite unlikely they all have equal impact. But yeah, I think the metric doesn't only work for the example, it works in general.
What would the overall distribution be? Of course, if I say mostly they have more or less the same impact, then MFP would just work as well.
Yeah, but mostly we find that they don't have the same impact. So there are very many small reviews, by small reviews, small randomized controlled trials, I don't know, with 20 or 40 people. And then, they're nice to have, but if you don't have them, then it doesn't really matter. Yeah.
Hi, Alan. Thanks for the talk. So I'm just curious that in which fields we could apply this idea. Is this only relevant to these clinical trials or basically clinical outcomes, or?
If what is relevant?
So this systematic review, I guess it is relevant, the examples that you have shown to the healthcare or the clinical trials or outcomes. So what are the other domains apart from the healthcare where this, you think this documents really matters, and their means different documents have different weightage in
Um, yeah, we haven't looked at that in detail, but for the data set that I showed you at the end, we also collected systematic reviews from computer science. I also didn't talk about those, but they're in the data set. And so we haven't looked at those in terms of the weighting because they don't use this same methodology with the diamonds and this table. But yeah, I think that's something to still look at.
Okay. Yeah, thanks.
Uh, does your approaches itself a gray literature or it uses gray literature in the overall process?
For the medical systematic
Yeah.
reviews, as far as I know, this is a point of discussion among the systematic review experts. So, because overall they should include everything, which includes the gray literature and also includes, for example, studies that are published not in English, which complicates things. So there's also a multilingual component to that. But yeah, I think there's a certain amount also of subjectivity involved in deciding whether it is relevant or not. But often they search beyond just I think usually they search beyond just what's in PubMed and so on. And they also try and find additional studies that are not included in in PubMed.
Thank you.
Any question?
Okay.
Thank you for the talk.
Okay, yeah, there is no tea break now, Bhargav, right? Okay. So there will be tea break, but a little bit later, don't worry. And so we are starting now with our overviews, right? One of the cores of the FIRE conference is evaluation. We heard a lot about evaluation. And now we start with the tracks where the real evaluation happens for different tasks. We have a committee and a small group that selects the tracks every year. We had lots of submissions, and this year, Kripa Vandu-Ghosh, who cannot be here right now, and me, we selected 10 tracks for FIRE for this year, and all went very well. So we're looking forward also for the next round. Yeah, so please submit track proposals if you have some good idea of some task. And we will have now the three first track overviews before the tea break, and we start with the which one? There it is. We have it already here. The spoken query cross-lingual information retrieval for the Indic languages. SQ Clear, very interesting. And Bhargav himself will be the presenter. Please, Mark. 15 minutes each track presentation. Over. Please.
Okay. So I am presenting overview paper for the spoken query cross-lingual information retrieval for the Indian language. We co-organize with DICT, Glasgow and Amsterdam University. So these are my outline. First, I will start with the overview of the track, then introduction, track timeline, participation, task detail, dataset, then summary of the method only for task 1 because we receive submission in only task 1, result, closing remark, and acknowledgement. So let's start with the overview. So if you see the document, so our track name is Spoken Query Information Retrieval for Indian Language. So for information retrieval, we require the document. So we have a bunch of documents here in Indian language. And we gave the query. So query is in speech. Like in Gujarati, if I speak something, or even I am speaking currently, that is also a spoken query or spoken thing. So we gave spoken query and do the searching, apply the searching on the document. So first task is we have a query, we have a document, and task is retrieve the document relevant to the query. And the next task is rank based on the relevance. Okay, so this is the main task, spoken query cross-lingual information retrieval. Okay, so these are the track timeline. So we started somewhat late. So we started with the on the 18 August we started open the registration and open the website. Then on 22nd August we released the train data, and on 8th September we released the test data. Then 14th October participate run submission deadline, and on 20th October result declare. And currently in between 12 to 15 we are at FIRE 2024. We are presenting this track. So next one is participation. So registration. So in task 1 we total we received the 26 team registration. In task 1 we receive 23 team registration, and in task 2 20 registration. Run submission, we received the total 4 run submission in task 1. I will explain about the task 1 and task 2 in a later stage. So we received total 4 run submission, and only 2 submission are valid. And out of 2, we got 1 overview paper, 1 working note. So we got a huge registration, we can say 26, but we end up with only 1 working note. So now I think there is some mess up. So we have 2 tasks. First task is spoken query ad hoc retrieval, that is monolingual track. And that task main aim is to develop a spoken query retrieval system which capable to handle monolingual spoken query. So monolingual means if you have a query in a Hindi, your document is also in a Hindi. So your task is to retrieve the document and rank it. And for this task, we gave the languages like Gujarati, Hindi, Bengali, and English. So simple image or view for that this task is that we have a query in Gujarati, like here, we give spoken query and we have a document in Gujarati. We do the search on the document and system will give the top K documents. So next is task 2, spoken query cross-lingual retrieval. So first task is monolingual. And next task is, the second task is cross-lingual information retrieval. So cross-lingual, so main aim of this task is develop a spoken query retrieval system which capable of handling cross-lingual queries. Or so basically your query is in one language and document in another language. Example is that you have a query in Gujarati and document in English. So your task is same. We have to retrieve and rank the document and required to provide the top K documents. So for this, we gave Hindi, Bengali, and English language, which has almost like if you choose the Hindi as a query, then document may be a Bengali or English in cross-lingual thing. And if you choose Bengali as a query, then document is maybe a Hindi or English. So like that wise, total 6 pair for the cross-lingual. So for this, I give the same thing. I give the same thing. So we have a query in Gujarati and document in Hindi. And we do the searching cross-lingually and retrieve and rank the document. I think with this introduction is over for my track. Now dataset part. So I think we all know that this FHIR is started with the FHIR collection. So we use the FHIR collection, same FHIR collection here for the document. So we say to the participant that you have to use the same document which is available in FHIR collection. And for that, you have to take access separately from the FHIR website. So FHIR corpus, which is available on website. Then we give or we contributed our contribution to this track that we created a spoken query data. So we created it using from the FHIR corpus. So FHIR corpus have queries. So each year they release the 50 queries. So total 200 queries. So first 50 query we release as a trained set. And 150 query, I think number is somewhat wrong, but 150 query, spoken query as a test. We also provided a query for the train 50 query. It's same from the FHIR corpus. We only extracted that. So this is about the data set. So I think I'm not giving the statistic of the FHIR corpus because it's already there in the papers and all. Now, summary of the method. So as I already said that we received the 2 submission, valid submission. So first team, that is from IIT Madras BS, means Bachelor of Science, Prabhu and Libin submitted this run for the English monolingual task. So there is query in English and document in English. So they use the dense retrieval. They use Whisper to transcribe the spoken query. And they use the embedding model, all mini LM L6 V2, and Similarity use the cosine to retrieve the document. Next one is Aswathama team. Nikhil Narayan and his colleague submitted this run for the Hindi, but Hindi, where they use the same thing, transcribe query using the Whisper. Embedding model is Paraphrase Multilingual Mini LM L12 V2, and Similarity they use the cosine. But if you see the result, this result is very low. I think maybe because this model not trained for the retrieval task or not trained on the Hindi model. So they not explain why they not submitted working note. So I'm not able to exactly confirm that what they exactly done. So result. So these are the result. So IIT Madras received the map. Map is also very low, 0.0414. But we got MRR, R at the 10, R at 100. That's almost comparable with the BM25. And Aswathama team receive very low score in all the metrics. So we can say that dense retrieval also comparable with I can say BM25, like because we are getting MRR 0.2414. It's good for the FHIR data set. If we check the previous publication on the FHIR data. So closing remark. So we successfully release a spoken query data. Currently we have a spoken query, one query. We have one query from the one person. So dense retrieval, as I said, dense retrieval almost good for the English, not Indian, but Indian English we can say, or comparable with the BM25, as this FHIR data set is only for the news domain. So that also that model which team use, that may be based on the general domain. So that not specifically news domain. So that also impact. So further planning to release the spoken query data by recording one query with multiple native language speaker. So one query, like one query in Gujarati, we figure out 10 people and ask them to speak same query. So multiple dialect will come because in India we have 22 language, and every I can say 20 kilometer dialect change in India, or every district dialect change. So that may be one good data set. We also planning to extend this to the RAG, Indian RAG. So maybe next year we offer the track with cross-lingual retrieval plus RAG. So one thing, as this is based on the FHIR, so I think I expect next time more participating this track. One more thing, we require volunteer to record a query, as this is for the FHIR and we are at the FHIR. FHIR data and we are at a FHIR. So if I get a help, if someone record the query in their native language, around 200 or 150. for the Gujarati, Hindi, English, Odia, Marathi, and other language. In other language may be required to translate the query by the human, but only 200 query are there. So if you are interested, I hope all are interested, because that's why you are here. So scan this QR code and fill the form. So that after the conference, we will contact you and ask you to record the query maybe within 1 month, because I believe in that. If you want to start some work, start early, don't do a late. Okay, so scan it or take a picture. We'll include all the other language like South Indian language, Tamil, Kannada, Marathi. Okay. So acknowledgement. So thank to the organizer of the fire for providing us the opportunity to run the track as a part of the Fire 2024. Also giving the opportunity to present the overview. Also acknowledgement to the native speaker who help us in creation of the spoken query dataset. Gujarati Bhavesh Baraya from DICT. Hindi and English Avnit Sharma, DICT. Bengali Parthiv Chatterjee, DICT. Also, I want to thank all who previously contributed in the fire collection. Because of that, I am able to do this. I am able to use this, because that's a huge contribution. Okay. Any question?
Thank you, Bhargav. Any questions? Curious, was very low participation. What was the problem? Maybe technological barrier? What do you think?
I think two problems. First, that very low participation is this is in Indian language. IR is not that much developed. As I've seen that even after BN25 or even BN25 paper is not published on Gujarati fire data, as far as I saw. And second thing, we have to fine tune this dense retrieval model for fire data, and maybe fire data is for domain specific, very small data. So that is the thing. Second thing is maybe we have to translate some bigger data like MS Marco. That already done by IIT Bombay recently. They have a publication in ACL 2024 that INDIC Colbert. So they translated MS Marco and trained the Colbert on that for the monolingual task. So for the cross-lingual task, there is no dense model present for the Gujarat, even Indian language. So from scratch, they have to start. One more thing, that what data released by IIT Bombay, it's not perfect. Many things are missing. So I requested them to update that thing. Let's see if they update soon, because already 6 months passed.
So the whole problem of lack of resources and technologies, that's why we have FIRE and can contribute to that.
Yeah,
Any
because
further questions?
Yeah. So it was really nice overview. So I have just one question, like that is seem odd to me. Like for the training set, we always have a bigger set, and for the test queries, we have a smaller set. But here it's like reversed. So we have only 50 training queries. So why is that? Like,
Uh, Actually, we recorded only a 50 query first, and then 150 later on.
But actually the training set should be like larger, right?
Yes, yes.
Yeah, then only it makes
Hmm.
sense if we are going to like use
Ye-
supervised
yes, yes.
models. Yeah.
So this query is already there in the fire data as a text form. So only we release the spoken form.
Okay, thank you.
Good, thank you. Then we move to the next track. It's Indian language summarization, and Shrey Kumar Satapara will do the presentation. Please, Shrey.
Oh, sure. So yeah, hi, good morning, everyone. And myself, Shrey. I'm from IIT Hyderabad, and I'll be presenting the overview of the shared task of Indian language summarization. Is there a way to hide this? Oh, works. Yeah. So this is in a collaboration with a lot of people from different universities speaking different languages. So now this thing is not working. Oh, okay. Huh. Yeah. So as I was saying, like the collaboration work with like a lot of people speaking different languages. So we offer mainly two tasks. The first task is, of course, the text summarization in Indian languages. Like we have been offering this task from last 3 years. This is third edition, and what's new in this edition is like along with the extended data set for previous languages like English, Gujarati, Hindi, and Bengali. This year, we introduced three more Dravidian languages, Tamil, Telugu, and Kannada. And of course, the extended data set for previous languages. So yeah, the idea is basically to create a CNN Daily Mail type data set for Indian languages where you're given a news headline and a news article, and you have to generate a fixed length summary for Indian language. So this is the data set statistics. For other languages, like we have added extracted data from the previous editions, and we have added more data for three new Dravidian languages this year. So the second task is more interesting, where we try to identify factually incorrect summaries given the news article. And so this is also a continuation from previous edition. Last year, we introduced the task. But this year, like we made it more challenging. Last year, it was a monolingual task where you are given article and summary both in English. While this year, it was cross-lingual, where you are given an article in English and the summaries will be available in Hindi and Gujarati, and you need to identify different level of factual incorrectness. So yeah, so we basically use adversarial prompting with different LLMs to generate the dataset for the task. We will look at the prompts soon. So these are the 4 categories that we have: misrepresentation, inaccurate quantities, false attribution, and fabrication. Yeah, these are the categories. Like, I mean, these are the classes in which we try to identify different errors. So yeah, so basically this is an example of a correct summary that we have extracted directly from a news website. This is the original English summary available in the news article, and this is the translated summary into Gujarati. This is factually correct summary that we have directly taken, and now we prompt LLM in such a way to generate factually incorrect summaries in one of the previously mentioned categories via using adversarial prompting. So the first example is misrepresentation. For misrepresentation, we have 2 different establishments. One is called Pro, where you are giving, where you try to generate summary basically in the favor of a particular entity. So if you see there are like some highlighted words, yeah, I mean, for Gujarati speakers, like you can, or like for English also, we have the highlighted words. If you see the original summary, like there are some additionally additionally added words, for example, swift action taken by local authorities to make it like pro-establishment towards the authorities. The second is anti-establishment for misrepresentation, where you try to misrepresent the authorities in a negative way. For example, here is the highlighted keyword saying that local authorities failed to prevent the outbreak, while no such thing was mentioned in the original summary. Second category is incorrect quantities, where you try to perturb the numerical quantity. Now, this particular thing is specifically hard. I mean, for human, it's very easy to distinguish. But when you try to conduct experiments with LLMs, like they fail to recognize this small perturbed numerical quantities. Third category is on false attribution. For example, in the original correct summary, if you see, like it involves municipal corporation taking action, but false attribution is instead of attributing to municipal corporation, they are attributing WHO for the same. And then fabrication, where you try to add like some additional fabricated info, while original summary doesn't have any mention of the reason. Here it explicitly mentioned that it is due to some genetically modified strain. So yeah, so in such a way, like we created article and summary pairs into Hindi and Gujarati for different news articles. So how the dataset was created? So basically all the summaries, factually correct as well as incorrect, like we use GPT-4 to summarize. And for the categories like incorrect quantity and misrepresentation, we selected articles in such a way like it should have some quantities to perturb the value. For misrepresentation, like we took specific topics where it is possible to generate biases. For example, if there is a conflict between 2 different entities, like 2 different countries, or some political controversies, some accidents like that. After generating factually incorrect summaries in English, we translated them into Hindi and Gujarati, again using GPT-4, and like then we did some additional manual filtering. So this is an example, like we use chain of thoughts prompting to generate different category of summary. This is an example of false attribution, where yeah, first you ask it to identify important entities, followed by different instruction, and one of the examples like how do you want to swap such values. Prompts like with respect to all the different entities is available in this paper, so feel free to check out. Yeah, so this is the dataset statistics for task 2. Like for the training data, we provided correct summaries in Hindi and English for all the data points. And then additionally, we provided some additional incorrect summaries for Hindi and Gujarati. In the training data, summaries were provided for both Hindi and Gujarati for each data point, while during inference, they were supposed to take a look at English article and summary from one of the languages. So yeah, for evaluation, we use RUG and BERT score for the summarization task. And we use F1 macro Now, another thing I want to mention about the test data of second task is it is possible to have like more than one incorrect or like more than one error in the summary. So during training, we only provide like a single label with each factually incorrect summary. But during inference, like there were multiple labels and participants were asked to predict any one of the possible label. And based on that, we did weighting while calculating the F1 macro. So participation, we got total 20 teams registered, and among 20 teams, total 107 runs were submitted across different languages and different tasks. We got total 13 papers, but then one was withdrawn due to logistic issues. So yeah, these are the RUG score for top three, RUG score and BERT score for top three teams on task one. For each of the languages, first is Hindi, then second is Gujarati. So the trends among all the teams were similar, basically. Yeah, I mean, scores for all different languages. Yeah, so trends were almost similar for all the languages, all top performing team. They did like fine tuning of different transformer based models. And we observed that like BART always performed better on English, while there was some swapping in terms of ranking while fine tuning Indic BART and MT5 on different hyperparameters. So this is the results for task 2. As you can see, like F1 scores for even like for the top performing team are pretty low, which indicates that detecting factually incorrect summary is still a challenging task. The approaches that people have used to identify incorrect summaries, like some people use traditional approaches like TF-IDF with classical machine learning based approaches, while the top performing team, they went with logistic regression with class weights and BERT with focal loss. Since there was like a lot of imbalance in the classes between correct and incorrect classes, I think that's why the focal loss was performing better. But yeah, there is a lot of scope of improvement in detecting factually incorrect summaries. So yeah, what's new for IELTS 2025? We are planning to continue offering the same task with additional task on probably cross-lingual summarization, where given the article in English, we will try to generate summaries in different languages. Probably like we'll look at like more granular level for misinformation detection, probably like detecting the corrected spans. And we plan to offer more languages for the summarization task. Of course, that's based on the availability of collaborators. So yeah, if anybody of you are interested in joining us for the summarization task, feel free to reach out to me. Yeah, thank you. Any questions?
Any questions for Indian language summarization task? Are you planning also new languages? Yes, yeah. And which any ideas already?
So we plan to look, I mean, we already added like 3 southern languages. I think Dravidian Malayalam is left. So probably we'll try to add Malayalam. And I think we already have 1 or 2 requests adding Marathi and Punjabi.
Okay, that you're already running. No questions, then for time's sake, we move on.
Sure.
Thanks, Ray.
Yeah.
And we move to the hate speech task, HESOC, hate speech and offensive language content identification. Ray is also part of that. So, but in the break, we will present Royal Bosch from Bengali, Bengal and myself. So let's see if we can manage. Thank you. Yeah. Well, can I use this mic? So you see a joint effort of quite a bunch of people. So thanks to all of them. Really, many people have helped out with HESOC. And Yes, there we go. Oh, yeah, and of course there will be some um, nasty stuff probably, but not so much, but please be aware of that. So we look back at already 6 editions of HAZOP with lots of languages. Many papers have been published here, and many people use these resources. And we see, yes, we can also manage to provide resources for several Indian languages with the help of so many people here and many others. And we have we had 2 tasks this year. These tasks only. One was in English, and one was in Bengali. So this was our 2 tasks here. We had the first one was and also first we looked at participation. So we had a rather medium-sized track this year, and we had 20 registrations. 11 teams then submitted, so the ratio is okay, now 50% more or less. And they submitted 21 experiments with finally 8 system description papers for the proceedings were submitted. We will then revise and we could accept all 8 papers at so task 1 English, we have binary classification, our typical scheme that we use, not offensive, hit and offensive, so not and off as we call it. And we ask our annotators to label for any hateful, offensive, or profane content, and on the other side, not anything else is and fine, and it's class not. Here we have 1,700 items, tweets collected from this was Twitter archive we used. So we downloaded one big Twitter archive from archive.org from back a few years back, and from there we sampled. And unfortunately, our Twitter archives are not produced any longer, so we have to look at this older data. Here are some examples. They are here from the English data set, and you see they are on the English Indian situation. We try to sample Indian content. We see off and not off and not. Okay. And here are the results, the submissions. We had 8 participants in this task. We see the first ones are very, very close together. So probably if we change the metric a little bit, they might also be interchangeable, and some fall back a little bit. And we see with F1 score of around 0.8, we reach the level of previous HAZOP tasks and also of other hate speech tasks in other conferences for other languages. So there we are doing, systems are doing quite well, we can say. That's probably about what can be achieved with our common methods and with this kind of data sets. Take task 2, Bengali. Maybe I switch over to Koel Ghosh.
For the Bengali data set, I mean, the task is task 2, and here first we consider a sentence, and we find out that it's offensive or not, and then we tagged that offensive post as a targeted or untargeted, and later the targeted test, we find out that whom we are targeting, I mean, to an individual or a group. So there is label A task of the task 2, that is offensive and non-offensive. And later we merge label B and label C, and we tagged as individual, group, and untargeted. So these are the samples taken from the Bengali data set. So these are the statistical representation of our Bengali data set. At the beginning, it's only the binary classification, and later it's classification of offensive sentences or comments. So these are the Bengali, results for of the participants. We didn't, participants perform little well in the task level 1, but for level 2, it's a little less. So methodology, participants use, they use the basic machine learning, and they use BART embedding as well. After that, using the BART embedding, they fed them to the CNN or RNN, and they use the zero shot approach at GPT also. And they use universal sentence embedding kind of things, and later they use LSTM. So in the conclusion, I want to say that probably next year we can introduce more languages, and we will focus on the reliability and analysis of the data sets. And the data set should be more diverse. So we will concentrate on that too. And another thing that is multi-model data. So nowadays it's a famous thing. Heads detection out of meme, and which is combination of image and text. Thank you.
Great. Thank you, Koyal. And, any questions for us? No questions? Oh, yeah, there is one. Yes. So, how are you? That's for the Bengali task. How was the distribution of the scores for the different diverse targets? Good question. We didn't analyze that, I think, no? We just analyzed overall scores. We don't have a score. Overall, the scores are much lower now for this targeted classifications, and we didn't look at that, but would be probably interesting for future analysis. Yes. Good idea. Any other questions? Not the case. Then thank you so much, and we can take the tea break now. Thank you.
Manish, क्या है? इसके बाद मेरा ही है ना सर? इसके बाद मेरा ही है ना? ठीक है मेरा 15 मिनट हो गया।
No, that's what I was saying.
Okay. Yeah, I did my MTech.
Yeah, yeah.
Under presentation.
Shankar told me that.
PDF. PDF. You want to next channel? Yes. Yes. I think sir will come today. Today night, sir will come. Hello.
So Barkov, we start again, huh? Then let's go for the next overview of the track, and this is the track on the shared task on code mixed information retrieval from social media data. So very interesting and relevant. And please, Supriya Chanda from IIT Varanasi PHU. Please.
Thank you, everyone. So I'm Supriya, and today I'm presenting like our shared task on code mix information retrieval from social media data. So this is the outline that I'm going to cover today. And the first is what is code mixing, like the mixing of two and more language in a single sentence. So this is happened all over the world with many languages. So like Spanish, English, and Tanglish. Okay. And code mix is a basically spoken language phenomena. So there is a example. This is a conversion between two people like lawyer and Minal. It's a dialogue from taken from Pink movie. So and we can see that there is a lot of code mix conversion going on. So code and this is a spoken language phenomena. But right now that we found this type of things in social media data in textual format. So globally, 3.5% of all tweets are code switched, and this data from like 2014. Right now, the percent is a little bit high, and 17.2% of posts and comments are Indian, like in Indian context, social media are code mix, and this is the study from 2017. So now what is like code mix information retrieval? So the basic definition is that query terms and documents belong to different language, which may be using their native script or non-native script. So like both query and documents can contain multiple language, but in our case, we take Bengali and English language, but the script is Roman. So basically the Bengali part in the transliterated form. Now the motivation. So basically now right now people move from one place to another place, and they make a community there to like their basic day-to-day life, the need of information they post in social media like this. So this is a group from Facebook like Bengali in Hyderabad, and they need something, so they put this post in a code mix format, and there are a lot of people who comment. But we don't have that much of time to check every comment. So we need the most relevant documents, like the most relevant comments top of the list. So how to do that? So from that, we make this problem is a information retrieval problem. So now the data sets. We all know that code mix data is not readily available in the internet. And so we collect the data from Facebook, like the post is in query format and the documents, like the comments in a document format. So this is the collection statistics. We collect 50 topics and 1 lakh, almost 8,000 data, like comments. And this is the data format. And this is the query format. This is the data format and the previous one is the query format. Now the team of participants, total 6 team registers before time, and 2 teams submit their system runs. They submitted 9 system runs. So Text Titans from IIT Kharagpur and Bits team from Bits Pilani. And the methodologies, like the one team used pre-trained transformer like SBERT and graph neural network, and another team used GPT 3.5 turbos, and the output they into a mathematical model and get the answer. So the results, this is the results and rank. So the Text Titans team submit 5 runs, and the last submit CMI 4 is the highest, and they rank first, and team beats second. So the conclusion is like, we want to thank FIRE 2024 track organizer to select our track, and LLM improved the performance a lot. And we want to extend our tasks with multi-script. Right now it's in Roman script, so we want to include like Bengali language in Bengali script, and we want to extend for other language. And also we want to use some domain specific. Right now Facebook, we collect the data is a mixed domain. There is like different kind of domain. So that's all. Thank you.
Any questions for? Yeah. Okay, then we move to the next slide. Thank you very
Thank
much.
you.
And we can go to click on script OQA. Yes, there we go. Gustav Rudra from Kharagpur, right? Right, so there.
Okay. So good morning, everyone. I guess I am audible. So this track is about this crypto QA. So primarily there are 2 tasks, that opinion extraction and the question answering from the cryptocurrency related social media posts. So we consider 2 social media. One is basically Twitter, another part is basically Reddit, and the language is basically English, at least for this study. So as you can see that
The organizers are basically, we have 5 members, Gaurav, Sogato, Shubham. They are basically students from IIT Jodhpur, Deloitte and IIT Kharagpur. And myself, Kaustav, I am basically presenting. I am faculty in IIT Kharagpur. And Kripa, you are familiar. He is basically also an organizer for this track. He is from IISER Kolkata, right? And this dataset is basically part of a paper which is basically recently accepted in this Schooling. You can see in the bottom that it is basically Crypto OPQA, a new opinion and question answering dataset on the cryptocurrency. So let's see. So about this dataset and motivation about this track. So you can see that basically as we are working on the social media for quite long time, so we come across many kinds of social media posts. So once we observe that this cryptocurrency is basically a popular topic and lots of people start discussing about these topics. So it is not like only single kind of statements. There are many kinds of questions, answers, as well as there are many suggestions about this cryptocurrency, because people, they are basically quite curious about where to invest and how to invest. So these things basically provide a ground for that. Now, we basically realize that it is basically important to investigate that what kinds of messages we have related to the cryptocurrency, as well as how can we basically meet the needs and requirements. So basically needs, you can see that people are asking where should I basically invest or which cryptocurrencies are good. This kind of needs are there. And similarly, there are also other users or participants, or you can say that experts, they can basically provide the answers to them. So the task basically remains, how can you basically match that need and particular requirement. So that's why basically we initially formulated these 2 tasks. Basically, how can you basically segregate these messages into different categories, and second, how can you match the need and requirements. Now, there are 3 datasets that we have initially released. One is basically opinion classification dataset of tweets, opinion classification dataset of the Reddit posts, and the third one is basically the question answering data. Now, what about this opinion dataset Twitter? The source is basically Twitter, and we have around 4,987 training samples. We have basically 500 test samples, and then we have basically 8 levels, and it is basically split across 3 different hierarchies that I will come. Now, what about the Reddit? Reddit also we have basically the training samples of 5,000, the test samples of 500, and basically the same thing, we have basically 8 levels for this particular task. And finally, we have the question answering dataset that is basically jointly curated from the Reddit and Twitter. So we have basically around 25,290 samples, and for the test samples we have given 6,324. And there are 2 levels, either basically answer relevant to the question or the answer is not relevant to the question. So it is basically binary. Now, how can you basically get the hierarchy in the opinion? Initially, we have the tweets or the Reddit posts. If we get to the first level, it is basically 3 categories. One is basically noise, another part is objective kind of statements, another kind is basically subjective kind of statements. Now, if you decompose the subjective part, it will come into 3 parts. Either it could be neutral or negative or basically positive. And finally, if you basically decompose the neutral part, it will give you either it could be neutral sentiments, or it could be questions, it could be advertisements, or it could be miscellaneous. So you can think about this as level 1, this as basically level 2, or this as level 3. Or otherwise, if you want to combine as a whole, these are 8 levels. Why? 1, 2, 3, 4, 5, and 6, 7, 8. So basically, if you combine as a whole, it will be 8 levels. And if you consider level wise, you have basically different number of levels in each level. Now, what kind of data sets we have? So these are the objective statements you have, like Bitcoin shoots past $50,000, adding over $70 billion. You could also have the statements like positive, like Ethereum making big moves in 2020. You could also have the advertisements like this much you can giving away by 20 lucky winners. So these are basically advertisements for a particular company or promotions. Now, if we come to the question answering datasets, what kind of statements you could have? You may have any crypto debit cards available in India. This is basically a question that you have in the media. You could also find an answer for that, like B21 Investing, they provide cards. So this is basically the need of the user. This is basically requirement. So the ideal objective, how can you basically match this need and requirement? The second part could be, what do you think is going to have the biggest search? You could also have the answers like Siakon are promising. If I have to stay on that list, I will say Polkadot. Similarly, you could also have things like, can somebody help me understand why crypto is a hedge against inflation? you could have this because crypto's appreciation in value outpaces Flat's depreciation in value. So these are basically your need side, and this right part is basically your requirement. So the objective is how can you match this need to the requirement more effectively. Okay, so this is basically your Q&A data. Now, this is the data statistics from the Twitter. You can see that subjectives around 1,745, noise is basically 1,553, and the objective statements are around 1,689. Similarly, if you have the level 2 or the subjective categories, you have basically positive statements 363, negative 69, and neutral around 1,260. And finally, if you go for the neutral category or level 3, you have basically neutral statements 177, questions 280, advertisements 677, and miscellaneous 59. So these are the decompose or basically the data statistics across 3 different levels. This is level 1, level 2, and level 3. Now, if I come to the Reddit, the distributions are a little bit different. The subjective statements are more, 3,852, noise 645, objective 503. Similarly, for your level 2 category, you have positive statements 259, negative 410, neutral 3,183. And finally, for the level 3 category, you have basically neutral 476, questions 2,390, advertisement 212, and miscellaneous 105. So this is the distribution across 3 levels for the Reddit. And the question answering data is basically for the test data. So this is the test data. You can see that most prominent part is objective. In the test data distribution also, objective is the most prominent class. Then you could have basically this class which is basically negative, then basically positive. In this way, the distribution basically rolls around. And if I come to the question answering data, from the training set, we basically the relevant pairs are 3,715 and non-relevant pairs are obviously more because most of the pairs are non-relevant. And for the test data, we have around 900 relevant pairs and around 5,500 non-relevant pairs. So these are the data statistics for this opinion and Q&A task. Now, what is the task 1 description? So you can understand that there are 8 categories. So given a particular post, you have to identify which category does this post belong to. This is a simple classification problem you can think about. Now, what is the task 2? Given a question answer pair, you have to determine whether this answer is basically relevant to the question or not. So basically we formulate this as a binary problem. We have to determine the relevance or basically non-relevant to that question. Now, this team statistics. So basically you can see that there are registration initially 29. Now model submission 8, we basically submit 8 models, and working note also 5, and later on basically fire registration 4. One guy, she basically didn't want to register. So this is basically ultimately the statistics for the participant. Now, so the first team is basically from the Mangalore University. So she submitted 2 deep learning models. The first one is basically simple. Both are basically LSTM based. What is the difference? This first model, she took basically all the 8 classes at once. So it will be basically 8 class classification problem. And the second part, she basically moves hierarchically. So basically, she first develop one model for the level 1, then another classification model for the level 2, and finally another classification model for the level 3. Both are basically LSTM based classification. Now, this team is basically from IIT Kharagpur. They are basically more tech savvy. So they basically delegate all the responsibility to the LLM for the task. So you can see basically for both opinion and question answering, they directly use the GPT-4 to solve their problem. So they do not put that much effort in the modeling. So rather they thought that LLM could solve the task quite easily. And finally, so yes, so basically their models are something like this. These are their opinion classification models. So they just feed the prompt and basically question and then ask basically tell me out of these 8 classes which part do you think. So they use this GPT-4 Turbo for this task. And for question answering, what they have done, they have provided 64 in context examples and just do this thing. So what they have done, these 2 opinion part, they have done 0-shot prompting, and basically for question answering, they have used basically 64 in context learning based prompting. These are the 2 methods they have applied. Now, if I come to the JEDGI labs, so what they have done, they have basically simple fine-tuning architecture, and they have fine-tuned different models like BART, Roberta, DBART, TwinBART, all these models they fine-tune, and they use the single classification level. So they thought it as an 8-level classification problem and solve the problem at once. So they participated in the opinion classification part. And finally, this team, so there are mixed up from different institutes like IIT Shibpur, IIM Kolkata, RCC Kolkata, as well as the Jadavpur University. So
they basically propose two models for the opinion classification task. So one is single level classification when they fine tune the XMBERT for the 8-level classification problem. And the second part, what they have done, so they basically put it into 3 different levels, level-wise classification. So if you check this architecture, this is basically their hierarchical architecture. So first they classify the level 1, and then from the subjective part, they basically classify it another into level 2, and then they took the neutral and basically develop another classifier for the level 3. On the other hand, another model, they just use the XLM Roberta and basically put it as an 8-class classification problem. So now, and for the question answering task, what they have done, so this is basically dual encoder architecture. One part they basically process the question, another part they process the answer, and then finally they basically concatenate and predict that whether this question and answer pairs or embeddings are relevant or not. Okay. Okay, so this is just the result overview from the 8 participants. So this is basically the stat from the 8 participants, one for the Twitter, another from the Reddit. Initially, we got the models and submission from the 8, but ultimately, as I have said, that out of these 8, 5 participants, they submitted the note, and ultimately 4 participants, they registered for the track. Now, in this case, these are the 4 participants, they finally registered. So we can see that this combined team, who are basically primarily from the Jadavpur, and they basically got this best F1 score of the 0.778 and Reddit score 0.542, followed shortly by this JED AGI Labs, so 0.761 and 5.515. Okay. And then finally, when it comes to the question answering task, 2 participants participated in this task. And here the IIT Kharagpur, they basically got the best score because it seems like this LLM basically understand the question answering relevance more better than this BART or LSTM based fine tuning part. So now what is the thing? So in the task 1, this combined team, they basically perform well. And for the question answering task, this IIT guys, they perform well. Now there are 2 takeaways basically from this result, that if the single level classifier, they basically works well, because if you go for the multi-level classification, there is a chance that the error of one level you are propagating to the next level. So far the results that we have observed, that single level or 8-level classification problem, they works well than the multi-level classification problem. And for the question answering task, although the scores are not that good, but this LLM seems to understand better the context than this BART or LSTM based fine tuning. Obviously the prompting will matter, and hopefully it will improve over the next round. Now, what is the conclusion? So basically, this is basically introduced from the Twitter and Reddit. We are planning to introduce from the other social media sources and extending this QA dataset. And finally, if possible, we can also include other languages than English, but that is always more challenging because local languages are always difficult to get. And we would like to thank the FIRE for letting us run this track. And we would also like to thank Aditya Barwal, so who is not part of this track, but he is part of this paper and that got accepted in the calling. So he helped in preparing this Reddit corpus. Okay. So thank you. These are all the participants for this track. And if you have any questions, I'd be happy to take.
Thank you so much. Not, maybe we can
Sure.
Then move on. System for differential diagnosis of GI cancer by Manjeera Sinha.
Hi, good morning. So Our track is on conversational systems for differential diagnosis of GI cancer. So I would like to set a brief context before going into the track details. Because when we plan this, it is kind of an open-ended shared task. The reason being that this is a problem that we are also exploring, and there is no such ground truth or annotated data for a system like what we are trying to achieve out there. So it's kind of like we wanted to understand how the community is also approaching a problem like this. So to give the background, GI tract cancer is kind of like it is the most frequent type of cancer, and it is the second leading cause of death. And if you can see that it is a very complex medical condition, because although we club it under the term of GI cancer, but it is actually different types of cancers starting from mouth to anus in any part of your digestive organ. And another thing is that currently there is an overall increase in the events of GI tract cancer in the population with lower age, younger age. Like in earlier, people would have thought that after 50 you get this get maybe the colorectal cancer, but now even at the late 30s people are getting that. So the worldwide this has become a huge concern. And just to give a reference that 3.6 times more patients die from GI cancer than breast cancer, but till now the discussions around GI cancers are very less, particularly from the standpoint of like how we can enable the physicians with technology for better diagnosis of GI cancer. So as I have said, like the diagnosis is difficult because under the umbrella of GI cancer, we have so many types of different cancers, and when we talk to the doctors or when we mind the different types of symptoms from biomedical literature, the problem is that most of the time they are very overlapping, like something like this vomiting can be present in more than the one type of cancers in the GI tract. So it represents a significant burden on the global health and their diagnosis is often difficult. What happens many a times, these symptoms gets overlooked or underestimated. Like people can think that they only have something like the irritable bowel condition, instead of like suspecting that it can be a type of cancer. And what doctors told us that many of times even the GI cancers are misdiagnosed for something like a gallbladder. So most times during very late in this stage, the cancer is actually detected. So these are some statistics. If you see that depending on the type of GI cancer, there are different types of survival rate based on how early in the stage it can be detected. And then in case of pancreatic cancer, although we have a lowest survival rate, but it is actually very difficult to diagnose to whether someone is going to pancreatic cancer or not. The reason being that often it is misdiagnosed as I have said, like digestive problem and other kinds of condition ailments. So what happens due to the misdiagnosis or more than misdiagnosis, in absence of effective mechanism for early detection or early screening, the mortality rates shoots up much higher than what it should be for different types of cancer. So as you can see, the delayed diagnosis can lead to up in the mortality rates from 20 to 30% from the 50 to 70% of cases. So what can be done? We can help the physicians in making more enhanced diagnostic decision, and also we can have an improved screening program. Of course, we cannot assist on the clinical part of it, but what we thought that we will be able to do, and we also discussed with the medical practitioners, that if there is a system which when given information about the background of the patient, the symptoms, maybe different tests, those are done. So it can give an probability kind of thing that how likely the patients to have the one of the GI tract cancer, and if not, if it cannot be sure, then what kind of test or intervention can be prescribed to have a better diagnosis. But as I have said, like there is no benchmark related to that at this point. So now artificial intelligence, what I have found talking with doctors, that there is kind of a very the reception is there, but it is also with very valid concerns. So while tools are used very very frequently for different administrative tasks, when it comes to the diagnosis, there is a kind of differences in the consensus around what the artificial intelligence can or cannot do, or what it should be trusted with and what it should not be trusted with. Of course, because the reason being there, the concern is what will happen to the false positive and the false negative in both directions. But what studies have found that although like there are concerns in the range of 40s, but more or less like 80% plus physicians, they are optimistic about the benefit of the artificial intelligence enabled diagnostic tools, not only the medical for the medtech devices and medical imaging kind of thing, but also things like, you know, conversational agent, and as our and also as we have seen, even for the review of the literature, because that is a huge concern, like it's a humongous task to be done. So this was our generalized task description, that development of a question answering based conversational system that can help in the early detection of GI cancer, given information of general symptoms, diagnosis and medical history of a patient. So as we do not have any annotated data as per se, like, you know, because this is not an kind of concrete classification problem, or there is no one correct answer. So it's kind of an detection about what can be the conditions and what can be the next intervention. So I will come to the evaluation metrics later. So what we did is that we made 30 question answers pairs like this to give it as a seed data for the participants. The idea though was that given the openly accessible vast amount of biomedical literature and other healthcare resources out there, the participants can leverage all these publicly accessible documents for PubMed or other repositories, the open domain medical ontologies, and with the help of these seed types of question and answer, they can come up with a system like that. So as you can see, this is like all this kind of this fictitious patients information, like the names and all, they are all made up things. So we have given like symptoms, vital, lab results, imaging studies, and then there is a question that this if there is a gastrointestinal tract cancer, and then what can be the next treatment, and what kind of these pathogens mutations are there, and then these are the responses. And for the evaluation of the developed model, we gave 50 questions like this. So very similar to the 30 that we gave earlier. And what we gave is that, so we first released this, what you can call that test data, and then we also later on gave them the ground truth levels for the test data. So after this, submitted the runs and the result on the test data, so that for their papers and working notes, they can evaluate on the test data themselves and can better understand how good their systems are performing. No, so now coming to the evaluation metrics. So these are the metrics that we had in mind, like what we thought will be relevant, but as you can see, not all of them are, they can be very quantitatively captured or concretely defined in mathematical terms, but more or less the participants have attempted to measure the goodness of their results in terms of these matrices. So the first one being the kind of concept, entities and relationships, those were correctly identified. So during the track description, we also gave them some pointers about what do we mean by the medical entities and concepts, what are the relationships, and what kind of ontologies are out there that they can leverage. Then the linguistic correctness and meaningfulness of the answers, because the answers are being generated by an automated conversational system. Then consistency, because we have seen in many cases there are canonical form of the medical terms, and then that basically to look into the confidence of the questions when doubted. That is to address the problem of the hallucinations. So the 12 teams participated in register for the track. So at last these 5 teams, they submitted their final runs, and they also submitted their working notes in time. So we will only consider these 5. So we do not have any ranking among the teams, because each team has a very different approach to this particular kind of open problem. So instead, we have looked into their methodologies, the kind of evaluation metrics that they have reported. And I will not go into very details of that, because when they present, so they can do better justice to these explanations. But just to give an overview, so this is one of the papers from the IIT Kharagpur team, which is kind of methodically sound and also well written. So, but again, so it is based on the GPT 3.5 Turbo. But we thought at first that every team that participate, they will rely only on the large language models. But what we found is that people actually also tried with BART-based architectures and some alternatives to large language models as well, including small language models like the BioMistral and Mistrals. So they have used 2 metrics to measure the entity accuracy and the linguistic correctness and meaningfulness. So probably they had the kind of best answers or the accurate answers to the questions, and it has also demonstrated that how prompt engineering can help in getting relevant answers for the particular medical queries without any kind of domain specific fine tuning or so. Next, people have the second group has used Robata and RAG, and as we have said, we told them that they can leverage the open domain medical literature, biomedical literature. So this group has utilized this 186,000 PubMed articles and to better develop a retrieval and a generation based model, both using a Robata large and the BioGPT. And this system was able to effectively interpret the complex and the unstructured users queries related to the GI cancers, and they reported their performance on the precision recall, FR score, the cosine similarity for consistency, and Levenstein's distance for the linguistics part, and it was found to be good. Our third team used a question answering system for, I think the next keynote speaker. So they have used the BART model, and what we have found that although they have tried to use some alternatives of the large language models, but the scores were relatively low. This can be due to the power of the model, and what they have said that this is due to the kind of limited data set. And they have also leveraged the publicly available data set from Wikipedia and other public resources. So the fourth team, they have developed a system based on this BioBERT natural language inferencing, FLAN-T5 and RAG models, and they have reported their scores on these following parameters starting from BLEU and ROOK to for the linguistic goodness and coherence aspect, the cosine, Levenstein and the coherence score. Lastly, the team, this is the team from BITS Pilani. Again, they have a very sound technique technique for the problem, and they have used quantized GPT 3.5 with a RAG model for their performance, and they have also compared the performance between the BioMistral quantized and GPT 3.5 non-quantized, and again GPT 3.5 with the improvement of their RAG model. So it was found that the quantized large language models with the RAG, it actually gave the best result. So I will stop here. Thank you. Any questions?
Thank you, Manjeera. Any questions from the audience? I have a question. So it seems like all teams used a different evaluation metrics. How does it kind of tie back to the actual accuracy of the prediction? So I see a variety of metrics, like somebody used ROOK, and then there were precision recall, and what was the last one? I think they also detected hallucination. So how does it all tie back to the actual accuracy of the prediction?
Okay, so this hallucination, so actually we do not have any number as per se, because they were kind of like, you know, we wanted to understand how the system can respond to this very specific medical question answering. But coming to the tying back to the kind of the labels or the answers for the test data, then some of the teams, they have used like these BLEU scores, and some they have looked into the kind of like the accuracy and the other part. So I can give you more details about the techniques later.
Okay. So okay, just a follow-up question. Is there a possibility of using some form of mixture of LLMs for evaluation as well?
Yes, yes. Absolutely. So because actually what we did is that while also generating the data, we took help of the large language models to understand some of the, like, you know, these clinical terms and the clinical descriptions and things like that. And then we went to the one of the oncologists, and we asked him to kind of to do a verification on the data, that whether it is medically correct, makes sense or not.
Thank you so much. Any other questions from the audience? If not, then we can move on to the next keynote address. Right. Looks like not. Okay. Just,
So my question is that, is the accuracy what we are measuring based on all the projects, is it purely based on the answers which are given, or is it also tracking the interpretability or explainability of the answers which are given? So I would like to mean interpretability or explainability in the sense that whether the answers which are given however it may be correct or incorrect, whether it is able to explain the correctness or whether it is able to give the trace how it reached to the answer?
Yes, so this is a good question. And so at this moment, we have not asked explicitly the participants to explain their, like, to account for the explainability. But yes, that is a valid point. And actually, apart from that technical explainability, what we plan to do is that how we can take some of the generated responses to the clinicians and get it evaluated by them, because actually the end users will be the clinicians, and this interpretability is actually a huge concern among the doctors. So the apprehensions that I mentioned about using an artificial intelligence based system for diagnosis, be it automated medical imaging prediction or things like that. So this is the one of the huge concerns among them, that how, like, they want to know the concrete steps of how the system is arriving to that decision. So that is something, of course, we will look into in future, but not in scope of this task.
Right. Any other questions? Thank you, Manjeera.
Thank you.
We move on to the keynote address now from Mohammad Nejadi. It's an online talk on LLMs and IR evaluation towards building reusable conversational test collections. Over to you, Mohammad.
Hello, everyone. Let me try sharing the screen.
Yes, visible.
All right, great. Can I start?
Yes. So
All
after
right.
the talk, we have an inaugural session. So if you stay after your talk, it will be good. So now
Sure.
you can start your.
All right. Hello, everyone. First of all, thank you very much for the invitation, and my apologies for not being there. It was a bit complex with 2 trips. I'm now in Tokyo, so it was very complex to arrange visa and stuff, and everything was delayed. So eventually, I decided to stay longer here so that I'm closer to your time zone and give the talk. And as was introduced, the talk is about LLMs and IR evaluation, and I'm going to talk a little bit about LLMs and IR evaluation in general, and then move towards the approaches that we are exploring towards building reusable conversational search collections. Who am I? My name is Mohammad Ali Nejadi. I'm an assistant professor at the IR Lab in University of Amsterdam, and my research is generally focused on conversational information retrieval, user simulation, evaluation, and recommender systems. And the talk of today is based on the work that has been done by my PhD students, Zara, Simon, Chuan, and Clemencia. So the talk is going to start with some review and some discussion on LLMs as assessors, mostly focusing on relevance label generation. And then I will talk about some of the risks and biases of doing so. And then some of the work we have done towards using LLMs as assistants or tools for evaluation rather than assessors. And then eventually I will finish the talk by talking about some ongoing work that we have in our track around nugget-based evaluation. So if you want to use LLMs as relevance assessors, I mean, there has been already a bunch of work for the past year on this topic. And there are a few advantages that have been mentioned or opportunities because these are really cheap, right? So compared to human annotation, LLM annotation is very cheap, also very fast. And then the annotations are typically very consistent compared to redoing it human. LLM is more consistent. It's accessible, so usually either you have it on your server or via API call, and it's also scalable for the same reason because it's cheaper and it's also faster. However, there are risks that come with it. There are a lot of unknowns, right? This is like a new era for all of us, and these models are huge. We don't know them well, we cannot understand them well. So we don't really know what we are stepping into. Like we don't know what if we start annotating with LLMs and then build collections and then use them for years. What would be the accumulated bias over years? They are biased, definitely. We don't have diversity. One of the powerful features of human annotation is that every time you have a new assessor, they come from different backgrounds, from different abilities. So this is very diverse, but with LLMs, we would be using the same LLM again and again. So we cannot expect something like considerably or hugely different. And then we could also start asking this philosophical question: do we really want models to evaluate models? Right? Does it make sense? Is it safe? And at the end of the day, what would we be optimizing for, right? So if a model is going to assess the output of my model, I would be optimizing for that model. I want to make that model happy, not the end user, right? So I will talk about this last point and others, obviously, more deeply, and then maybe that's also something interesting to discuss at the end. As I mentioned, there are already a bunch of work on this relevance assessment. So there is a lot on prompt engineering, papers working on zero-shot prompting, or papers with one or few shot examples. And there are also works that try to fine-tune open source LLMs for this task. And this, you can see that this paper by Fagioli and others last year at ICTIR was basically the first paper that brought this idea of using LLMs as relevance assessors, right? So this was the prompt they used in that paper. Let me see if I can make it a laser pointer. Okay, this is better. So this was the prompt they used, and they used it on ChatGPT and also U.com. And this was the out of the discussions they had in a seminar. This was the spectrum of involvement of LLMs for assessment. So it could go from purely human judgment, that's what we used to have, all the way towards fully automated relevance judgment. So if you haven't seen this paper, I highly recommend. So this is very inspirational, and you can also see their point of view on how LLMs can be involved at different levels. But what they do is that they test this last option, fully automated, right? So we already have no LLM involvement here on the top. And then they wanted to test the fully automated setup to see how reliable that is. And that's what they found. Like, so I'm summarizing this paper a lot here, but basically what they found was that if you look at the absolute labels, right? So is this document relevant or not? Does human agree with LLM? There is not that much of an agreement. So the agreement, I think, was around 0.4 if you take COPPA agreement. However, if you use both labels to evaluate systems, for example, in terms of NDCG 10, and then rank the systems using human labels and using the LLM generated labels, we get a very high correlation, Kendall star of 0.86. That means that even though the scale of the labels probably is different, is shifted or is biased, they are still pretty consistent with human annotation in terms of placing a model at the right place in the ranking. And then with this introduction, I want to move to a more conversational setup. Before that, I want to introduce to you a track that we are running. So for those who do not know, Trek is also an evaluation forum. So you could say it's an American version of FIRE, run every year in the US. We are organizing a track there called ICAT, Interactive Knowledge Assistance Track, where the focus is on conversational information access. So we organized ICAT last year for the first year, and then after it was finished, the data was there, we were like, okay, let's also work towards building some models, right? So we tried different models. We got some inspiration from the submissions, and we had some ideas. And this was the results table, right? So what is the strange in this result table is if we look at these models here, these details are not important. What is important here is that all the models here are GPT-4 based, so they are slightly different, but not that much. They are all using the power of GPT-4. However, if you look at NDCJ5, the numbers are very different. So 0.2, 0.4, 0.2, 0.2. So then we were wondering what's going on here because, okay, they could be slightly different, but this is a huge difference for two models that are both based on GPT-4. And the same happened, like we could see some like models that are like you would say they are less powerful than GPT-4 and they are doing better. For example, MonoT5 here, 0.22 compared to this GPT-4 model 0.20. So it didn't make sense. So for some time we were wondering what's going on, what's the problem? And then what we noticed was that we looked at the documents that are, so if you take a collection like an already assessed pool, and then you want to basically run a new model on it, right? So what you do, you just take that and everything that is not in the original pool, you consider it to be zero, right? And the problem was that, right? The problem was that we had a lot of unjudged documents in the top 10 results in ICAT, right? And that's why we had a huge difference here because this model was in the original pool. So you see this is judged at 10. So this counts the number of documents in the top 10 results of this model, top 10 documents of this model that were judged by human in the original pool. And typically, if you want to have a reusable collection, this number shouldn't be that different between different models. So it should be around the same because we don't want a model to be like punished for bringing up new documents that are not judged because anything that is not judged is considered to be irrelevant. In this case, in the top 10, for example, around 6 documents, more than 6 documents on average are just assumed to be irrelevant. Whereas this probably is not true because they are not judged and there are some of them that are relevant. So that's causing the bias here. That's causing the disadvantage of the new models in this setup. So we were like, okay, so what can we do? Like, can we use LLMs to improve reusability? And if we consider these unjudged documents as relevance holes, as assessment holes, can we just take these holes, assess them with LLM, and then patch them back, put them back in the judgment, and then have a fairer, have a more realistic assessment? So that these were the questions we were trying to answer at this point. And then we went on with a few approaches inspired by the related paper, like for example, the paper by Fagioli and others, we thought, okay, let's first regenerate all the labels with LLMs, and then we do the same, right? So we generate everything, we replace the labels with new labels, and then we compare the results, we see what happens, right? And then the results are similar to what we already saw in the other papers, right? If you look at it, the absolute labels, like the label itself, there is not much of agreement between LLM and human, 0.4. So it's moderate agreement. And if we train Llama 3 on the data, the agreement goes high, really high, because it learns the task better. But then if we go to the ranking, which I have in a couple of slides, we see different results. But so the findings are not very different. We see that one-shot GPT is the best, and then among GPT models or among in-context learning models, but fine-tuned Llama outperforms GPT by far, right? 0.7 versus 0.4. However, when we rank the systems, right? So when we take all the new labels and then we use these labels to rank systems, and then we compare this ranking with human generated ranking, we see a different story, right? So we see that even though these are GPT models, even though GPT was not doing well in predicting the labels compared to human, in system ranking, it's very close to human, right? So 0.85, for example, when we consider NDCGF3, while Llama is not doing as good, right? So it's still okay, acceptable, but GPT outperforms. And so our finding is that if you want to have the absolute labels, like Llama is better, but at the end of the day, GPT does a better job in rank. But what does it mean, right? Why there is this discrepancy here? So then we've moved further on a more realistic setup, right? What is the more realistic setup, right? So in the table you saw earlier, right? So I have a new model. I have already a pool of, for example, 30,000 assessments. I wouldn't want to reassess 30,000 documents just because I have another 10 documents to add to it, or another, I don't know, 100 documents to add to it. Because that's what we did before, right? So we regenerated everything. So assuming that we have a new model with some unjudged documents, the ideal situation is where you just reassess these new missing ones, these holes, and then you add it to the original pool. To simulate this setup, we have this leave one model out setup, where we basically simulate this, right? So every time from the original pool, we take one model out. We take everything that this model is related to this model and only this model out, like documents. So assuming that that is the new assessment pool, and then when this model is compared against this pool, it means that it will have a lot of missing documents in theory. And then we use an LLM to assess those and replace them. And then we repeat this process for different models, right? So every time we just take one model out, we do the experiment, then put the model back, another model out, and we repeat this. And this is what we find here. What we find is that, again, even though ChatGPT or GPT-4 3.5 does very well in ranking the systems, but it does not do well when you just want to patch the labels, right? So this is the absolute distance of a model with human and with GPT-generated labels. So which means that I take the ranking of the model with original pool. Let's say the model is ranked second, and then I reassess everything with GPT, and then I look at the new ranking. Maybe the new ranking is 5, and then the absolute distance is 3. which means that if it's 0, it's the optimum, it's the best, right? And we see here, actually Llama does pretty well, right? So it's always like 1 or 2 or 3 difference, which means and ChatGPT is really, really bad. Like you see, as the number of unjudged go high, we see that it really, really affects, like the distance would be very high. And what we observe is that GPT is usually more positive than human, right? So humans are really picky, and it's really the document should be really, really like fully relevant for humans to say, for example, that this has a label of 4, while ChatGPT does it easier, like it's more easygoing, let's say. Therefore, anything that you have there, and then you replace it with GPT, the labels are higher, and then it's just inflated, right? So if the ranking is 10, usually when you replace it with GPT, it goes high. Maybe the ranking becomes 1 because it's just a different scale. And that's why it's just best to assess the whole pool using GPT. If you want to use GPT to fill these holes, you cannot just fill the holes, you have to redo everything. Otherwise, you can, for example, fine-tune Llama 3 for this task, and then just use Llama 3 on. So you have a bunch of labels already. So that means you can use Llama 3 to train the model, fine-tune the model. Then you can use it to fill the holes. There are some works that came out later or around the same time, which repeated the same experiment on TrackDL. Their findings are a bit different, but also their experimental setup is different. So if you see in their experimental setup, they use GPT 3.5 and Vicuna, and then they also remove labels. And as they remove more and more, they look at the tau value, the correlation, and then we see that GPT is doing better than Vicuna. What we observe here, I think there are a few things that are different here. We don't want to say which one is better, but it's different. One is that this is not a leave one model out setup, which is completely different than what we did. This is just randomly removing labels. I think leave one model out is more realistic because that's actually what we need this for. So we better just test it on that. And this is also tau value, Kendall's tau value, which is a little bit, it's not a good metric to measure this because the differences are not that much. And as a matter of fact, if you look at these two values, they are very close, like 0.9 and probably 0.95. Whereas if you look at these, it's really pronounced, right? Because it really shows the effect of that rather than just a number like a correlation number. All right, so this is, let me stop here for a bit. So this was the kind of context I wanted you to have, like the background on using GPT, like LLMs for relevance assessment. There are some new works, more recent, very recent. So I did not mention them here because they are too recent. I still need time to read, but this is basically the gist of it. If anyone wants to ask a question now, let me know. Otherwise, I just move to the next section before it's too late. So let's then continue with risks and biases shortly, and then we move on to the next part, which is using them as tools. So I have this example here, right? So assume that you're a human assessor, right? And then your task is to assess if this document on the right is topically relevant to this query, population of Amsterdam in the 18th century, right? So what would a human assessor do is to start reading this document from top to the bottom and then try to find the pieces of information or the answer to this question or this query. The problem is that This is a very, very long document with very convoluted text, and it also needs connection between different parts. So there is a lot of room for human error and human fatigue, because we are human, right? So if we start reading this complex document, we get tired, and if the next one also. Moreover, if you also are the end user of this, would you really go that deep to find the answer, or you want the answer to be given to you? But on the other hand, if you give it to an LLM, it immediately tells you that this is relevant, right? So because everything that I mentioned does not apply to LLMs. They don't get tired, they don't get bored, they don't get fatigued, and they are very usually accurate reading long texts. So LLM can easily find the text. This is the part that it partially mentions the answer, and then there are other parts as well that you combine, you can give the answer using this document. So here's the problem. So this is the problem that was mentioned in this paper, where they have this novel data set that is created for federated search within RAG frameworks. And they try to study LLM-driven derived relevance judgments, and then they compare it with human, and then they found these disagreements, like they were not able to explain why human says it's irrelevant while LLM says it's relevant. And they found that this was the problem. The documents were too long, too complex for human to understand or follow, while it was very easy for LLM. And then the question is that, who is actually the end user of the system, right? Or is the assessor, is the LLM assessor right for the wrong reason? Do we want this document to be judged relevant for human as end user, or for a RAG system as end user, or for a search agent as the user? Because if this is a search agent, or if this is a RAG system, I don't care how long or convoluted the document is, it can just read that part, give it to the user. So at the end of the day, the user is happy. But if the human wants to consume that document, then we have a problem, because I probably can find a document that just mentions this, and it's much easier for human to read. They don't need to read a lot about the European history in different centuries before they get to that response. Another bias that we have, so that was one bias, by the way. That was like, I don't know if we can call it a bias or an observation of the difference of the behavior. But another bias is the positivity bias. So we know that LLM, like GPT, is in general more positive, so it's easier to be satisfied for different reasons. One reason is also relevant to the previous one. Again, human could read a very long document and say, no, this is not relevant because this information is not visible. But for GPT, it's like, it's there, I can see it, it's obvious because it's a model, right? So that's another bias that we have to have in mind. And then there is another bias of query term overlap. There's this recent work that was basically presented earlier this week at SIGAR-AP in Tokyo that looked at this phenomenon of if we stuff query terms into documents randomly, or the whole query word at some point, actually GPT can be full, GPT-4. So if you look at it, so it could go up to 35% of cases where GPT just wrongly says this document is relevant while it's irrelevant, just because the query terms are there. So this could be seen as an attack, for example, to a GPT assessor. And then there is a study last year that showed LLMs in general are narcissists, right? So if you have a model that generates a text, and then you use the same model to evaluate the text generated by different LLMs, as you can see in this figure, they prefer the text that is generated by themselves, which kind of makes sense because it comes from the same distribution, it's the same language model. Of course, they think that their own text is better. And we exactly saw the same thing at ICAT, right? So we used GPT-4 to assess generated content based on groundedness and naturalness, and then GPT-4 model turned out to be the best one, which was not surprising because the model was good anyways. But what was surprising was that naturalness was rated as 4 out of 4, which was a little bit, I don't think we can never, there is always room for improvement. We can never claim something is perfect. So yeah, I think that really aligns well with the findings of that paper. And I think that's all about risks and biases. And then I want to quickly talk about 2 works that we did, where we tried to use LLMs as annotation assistants or tools. One is the work that we had at NACL earlier this year. So the task is to label a turn in a dialogue, right? So imagine this is the dialogue you have, and then you want to assess this turn as like in terms of relevance or whatever. So the problem is that a lot of these dialogues can be really, really long, right? So, and then the topic can shift. Again, the problem that we said, fatigue, a lack of attention of human. So we thought, oh, okay, this sounds great. We can just use LLM to summarize this for us. And then human just says this, based on this summary of the conversation and this last part, is it like a good dialogue or not? So it all made sense, right? So you save a lot of human effort. It's a shorter text, is processed, and it's easier to consume. However, we did not see the improvement we were hoping for, right? So if you look at the LLM-based model, so this is the COPPA agreement between different workers, we see that it decreases, right? In both cases, both for relevance and usefulness. So we were a bit surprised by this result because that was not what we expected. Although in terms of efficiency, it was expected, so they spent less time, but in terms of performance, they didn't do that well. So we hypothesize there are multiple reasons. I mean, the summarizer is not perfect. The text could be confusing, and maybe the annotators are just not used to this type of summaries yet. So they need a little bit of time to learn more about LLMs and what they can do, or what conversational summaries is. So we have some hypotheses that why this didn't work, but I think it needs further study or further like trials in different tasks to really see what's going on. Maybe it works at some point, but currently this was something that we observed that actually we could not get it to work. And then in another task, we tried to use LLMs as a pre-labelers. What does it mean? Let me give you some context. So we saw that we can use LLMs for relevance judgment, right? So if you look at the confusion matrix of these assessments like this one, so what we observe is that we have a lot of, like very few false negatives, right? So which are these ones? Compared to others, false negatives. So that means that if the LLM, let's say in this case GPT, says this document is irrelevant, it probably is irrelevant. So it's less likely to be relevant because we said earlier, GPT tends to be easygoing in terms of relevance. So if GPT says this is irrelevant, probably likely it is likely to be irrelevant. So we take this finding into account. We say, oh, okay, so we have in traditional pooling, we have different systems, right? And then at some point we draw a line, we say we want to do top 5 pooling, right? And then what we do is that we take the top 5 of all the systems, we start assessing them by human assessors. Everything below is considered to be 0, right? Irrelevant. What we can do this time is we take the LLM, we run the LLM assessment on all the documents. Let's say we go deeper, top 10, top 20, top 30, and then the LLM tells us which ones are likely to be relevant or irrelevant. And then we take human to only assess the ones that LLM predicts as relevant. because we say there is a high chance that these are actually irrelevant. And that's actually what we saw in ICAT. We tested this approach in ICAT. So ICAT 23, we just did traditional pooling and was top 10. And then in ICAT 24, we did this approach, which we call dynamic pooling. So we went up to top 30. We used GPT-4o for pre-annotation. Because we do not trust it yet, we still annotated the top 5 always with human, and then from 5 to 30, we only annotated the positives. And this is the statistics we had, right? So even though in ICAT 24 we had more submissions, the total number of annotations was lower, right? So that was something interesting to see. We managed to get less annotations, and then if we look at the distribution of labels, so this is irrelevant, 0, right? So we see it's 10,000 in ICAT 24 versus 20,000 in ICAT 23. So we are able to save this much of human assessment time, because this is actually, you could say this is wasted assessment time, because they just say this is irrelevant. And then if LLM can help us save this time, great, right? And then you can see the numbers for slightly or moderately relevant or fully relevant is also in most cases higher. So in theory, so what in conclusion we see here that we are able to have less annotations and less irrelevant annotations, which is saving a lot of assessment time. However, we do not exactly know what type of biases we are injecting there, right? For example, if next year I'm participating at ICAT and I know that participants are doing this, I could just run GPT on my top list, top 50, for example, throw away all the zeros, right? And then re-rank all the non-zeros, right? So I already filter out. So there's a very, very high chance that I do very well at that point. Or what if I just use GPT as a re-ranker? So it's GPT wouldn't rank those 0 documents at the top, right? So it's again narcissism of LLMs and stuff that I just mentioned earlier. So we see there is a problem here, but we are still trying to figure out. So this year was easy because nobody knew that we wanted to do this, but for next year, we need to be more cautious not to have this problem. But also I'm very interested to hear in hearing your opinion about this, or maybe ideas on how we can tackle this problem. So summary of this before I move to the last part, which is quite short last part, so I think we can still make it in time. So intuitively, we assume that LLMs must be able to help humans in by giving a summary of long text, but we didn't see that, right? So it's more efficient, less time is taken, but it's not effective. Actually, it makes the assessment agreement between different assessors less. And then we saw again that LLM assisted pools can help us be more efficient, but it has some unknown effect that we still need to study. So that's what we are currently doing. And then some ideas that we are trying this year at Trek already, and then we want to evolve it to next year. So this is also a way to encourage you to look at Trek ICAT and maybe participate, because I think there is a lot of cool things happening there. Is about how we can evaluate RAG systems, right? So if you so the whole idea of RAG system evaluation is that you have a text that is generated by the system, and then it has some citations to documents, right? So it says, this piece of information, I got it from this document. And then the idea is that the task is that we are first looking at how good these citations are, how good are these documents that are cited, how good is the generated text itself, and how complete it is, right? So because it could just have different 10 aspects, but then the answer just mentions one of them. So that's not a comprehensive and complete answer. So in a sense, if this is the generated text by a system, then we want to break it into smaller pieces of information units or information nuggets. And then what we can do is to go through each of them and see which one is relevant, slightly relevant, and irrelevant, right? So that would be one way to go. And to do this, what we do here is that we take different systems, right? And then we take the pooling we saw, and then we ask the assessor to go through these documents, tell us which one is relevant. And then once they do this, we ask them to also extract nuggets of these documents. So definition of nugget is that highlight a piece of text that you think you can use to generate a response. And then we have a gold set of nuggets here, right? So we have these 5 nuggets here extracted from all the relevant documents. And then we ask the same annotator to generate a response. And in a lot of cases, these annotators could actually extract a lot of nuggets, but only use a few of them in the final response, right? So it's not that they always use all of it, because, okay, it can go really long, right? So you can have a huge response, which might not also be very consistent. So what we do at the end, so if we have a new system, let's say system A submits this response, and then we extract these nuggets from system A. And then on the other side, from the data, we have already the gold labels, gold nuggets and the gold responses. So we have these 2 sets, and we know which nuggets of the gold set is in the gold response. Then we can compute a bunch of automatic metrics, some surface-based metrics like BLEU and Rouge, semantic similarity like BLEU score or Bergen. Once we have the nuggets, we can compute the nugget recall, nugget precision. We can even do groundedness or have terms that have no answer, and also see how the models do in terms of hallucination, because that's when we know that they are absolutely hallucinating. And it was interesting to see that in Trek, probably also in Fire, there are different tracks that are doing slightly different but very similar things about RAG evaluation. So if we compare Trek ICAT with Trek RAG, we see that in ICAT we have human-generated gold nuggets, as I just showed to you, whereas they have LLM-generated gold nuggets, but then human edits them, so maybe they save some human time there by doing that. And then in ICAT, we have gold human-generated gold responses. They do not have that. And for evaluating new system, they do LLM-based nugget matching and extraction. We do the same because basically there is no other way to do it, right? At the runtime. So in summary, currently the research in RAG evaluation is mostly focused on nugget-based evaluation. We think that having gold responses can ensure the evaluation in terms of readability of the generated response, or the narrative, or the coverage. And then, of course, we know that one gold response per query is not enough. We need way more than that. So maybe in the future we can really study having more than one gold response. And then yeah, like there are a lot of tracks in Trek, in Clay, NTCIR, and Fire doing RAG-based evaluation. So it's exciting to see what comes out of this, and like what would be the real innovation at the end. And there are also ideas that we are exploring for next year, ICAT on nugget-based simulation. So we use the same technique, but then we use nuggets as a way of computing utility in a simulation, so that we can have these simulated dialogues. I want to end my talk with a little bit of advertisement on the 2 workshops that I'm co-organizing, so related to the topic that I covered today. So if you find these topics interesting, you can look at the works there, or you can participate in this workshop, submit. LLM for Eval workshop, the second edition is happening in Wisdom 2025. First one was in SIGAR 2024, a very successful workshop, so I highly recommend it next year. And we have a new workshop by all the RAG-based track organizers of Trek. It's called Eval for RAG. So basically, we want to go there, everyone talk to each other, discuss what we are doing, what we need to do. And we are inviting everyone, because this is a very new topic, to submit a short abstract or extended abstract. So basically, we don't want papers. I mean, we still invite papers to submit, but we mostly care about to make it also easier for people to come and discuss. If you have an idea, like if you listen to my talk and say, oh, we can do this or that, or this is a problem, or this is the bias, or I have answered to some of the questions that you asked, you can basically submit a short abstract there, and then that's kind of a seat for discussion for at the workshop, and then you present your ideas, and then we have a discussion group after, which I think would be quite interesting. So please consider this. Everyone's invited to submit. And that's about it. Thank you for your attention. Would be happy to take questions.
Thanks a lot, Mohammed. It was a wonderful talk, and so many new ideas about how evaluation would look like in this post-LLM world. Certainly, things are not going to stay the same. It's nice to have this discussion. Audience, any questions? Yeah, I have 2 questions for you. This one is more broad, like with new LLMs being trained almost every other month, and most of these evaluation forum data sets being in public, how reusable are really the collections? Like once it's in public domain, like the new LLMs, new versions, they'll already know about these data sets, right? They'll be these will be part of their training data. So how reusable are really these data sets anymore? Or do we kind of
That's a great point. I think I'm gonna add it as one of the risks to my slides later. I absolutely agree with you. So I think that is a problem that is very hard to track, because even though these companies claim that they mention publicly what datasets they used, there is a lot of doubt that this is actually the case, and at the end of the day, how many people actually go and check it. So I think this is a problem, definitely a problem, and I would say it's not easy to fix. So it puts the reusability of these collections at risk. And we might probably need to standardize this. So perhaps some sort of screening of these models, and then an automatic way of saying, okay, these models have this collection as their training, or if you are doing better than this, probably your model is just seeing the test set. Yeah, I cannot think of any other way, because if the model has seen the data, that's it. Like, what can we do, right? The task is solved.
Right. So maybe some sort of evaluation where like threat collections are used over the years, right? So maybe some held out set or some new addition to that collection every year. So instead of it being a static collection, there is like over next 5 years, there are few additions, and you see like how it performs on those new additions and how it performs on the set which was already public. Maybe very
Yeah.
expensive, yes, but that could be one way.
Yeah. While the track runs, so usually the age of a track in Trek is 4 years on average. So while the track runs, I think that really works because naturally, there will be new collections, and then okay, there is no way that they can these LLMs can know the new collection. This is held out and stuff. But unfortunately, once the track is over, then there is no more incentive for the organizers to continue this. So, but on the other hand, maybe we can think of LLMs as data generators or as simulators as a way of also tackling this, because, okay, you can consume the whole data, but learning from a model, a specific task is less likely to happen in the near future. And so I think probably at that point, simulation-based models could be a better option.
Thank you so much. I have one more question, a little more technical. So LLMs are known to be like creative in nature, right? Like they try to make this temperature setting and which kind of tries to give you a different answer every time. How does that work for assessment? Like, is it consistent in reruns or is it kind of controlled usually?
We actually tested this I went through this slide quite fast. Oh, I need to share my screen or. So while you're fixing the screen, I can tell you about the experience. So what we had is true, like as you increase the temperature parameter, you increase the creativity, but the performance goes down significantly because in a sense you leave more room for error. But there are works, for example, works that are related to LangChain as well, that they show that this way you could actually simulate the scenario of crowdsourcing, for instance. Right? So in crowdsourcing, you have 3 labelers, and then you aggregate their. Maybe I can share again if it's complex to fix that. Let me see. Yeah, okay, I think it's now visible. So going back to the slides, you see temperature 1, temperature 0 is less, but as I was saying, there is another paper that studies using temperature and regeneration as a way of aggregating simulating aggregation of the label of different workers. And they also show that you could increase reliability and decrease risk bias in this way, but it's not to the perfect level. Like, so it works a little bit, it's better, it's more expensive, obviously. But yeah, that's one way you can use temperature.
That's very insightful. So it's not necessarily a limitation. It can actually be a strong point.
It is a strong point, yes. If you do it multiple times, if you want to do it only once, you can see the results. I would say temperature 0 is the best.
Right.
But yes, in the framework of LangChain, for example, or if you want to treat it as a crowd LLM setup, where you, for example, run it 3 times and then take the majority, it actually works better.
Thank you so much, Mohammed. Any questions? If not, then we will move on to the inaugural ceremony. The director of the ICT will be joining us. Right. Thank you, Mohammed. Thank you so much.
Thank you very much.
as
Thank you
Bhargav
everyone for
mentioned-
your attention.
As Bhargav mentioned, we hope you can stay back for a few more minutes for the ceremony. And
Yep.
So now we have a inaugural talk, and we have Tathagata Bandyopadhyay, director of the DAIICT Gandhinagar. So, sir. So,
I think I'm not supposed to give inaugural talk. I'll possibly talk for 5-10 minutes. So, welcome to this DICT campus, and I hope you already saw the campus. It's one of the most beautiful campus in Ahmedabad, what I see, because I was in IIM Ahmedabad. So it is much better than IIM Ahmedabad's campus. So nice that you came from different parts of the world, and I'm happy to welcome you, and I hope that your stay would be comfortable here. I would like to tell a little one or two things that I think not about information retrieval, because I don't know much about it. So I thought maybe I will talk a little bit about something which I know a little bit, okay? So first of all, today morning, actually, I was giving a lecture from 10 to 12 for the faculty and students of a university. I was there. That's why I think I couldn't come on time. So the lecture was on correlation, causation, and machine learning. Okay. So basically, finally, I told them, I gave them an example and I asked them question. So I told them, suppose there are 2 million people, you have data on 2 million people, and the rows are smoker and non-smoker. And the columns are had lung cancer or not. And you see that out of 1 million people who are smokers, 0.99 million people got lung cancer at some stage of their life. And out of 1 million non-smokers, 0.99 million people didn't have lung cancer during their lifetime. Okay, so give this data to a machine learning algorithm, prediction will be very, very accurate. If you are a smoker, you will have lung cancer. If you are a non-smoker, you will not get lung cancer. My question is, can I say that smoking is one of the major causes of lung cancer? So can you answer this question? So there are lots of debates on that. Eventually we found that it's not possible from this data to answer this question. You possibly understand that correlation doesn't talk about causation. And so the problem that I see in machine learning, first of all, I don't like it a lot because the deep learning technique, although it is doing wonder, but as a scientist, if you look at it, you will feel very frustrated because it's a kind of black box and you don't know what's happening inside. And possibly what it is doing, it's creating a kind of very, very complex function which can give you a very good approximation of the predicted value, and that's why it is working. But what's happening inside, we don't know. So if you look from the perspective of a scientist, it's not good because we don't know why I'm getting this. That next question, the question that comes, explainability and fairness, all these questions now the machine learning researchers are talking about. But there are good things that it is doing also. So for example, I am following Demis Hassabis for a long time, maybe 2-3 years, because I am a fan of him. And he got the Nobel Prize this year in chemistry for his AlphaFold. So I was listening to one of his lectures. What he was saying, very interesting. He's a perfect scientific mind he has. He was saying that, see, what we are doing through this AlphaFold, we have a search space. So different, for example, he used to, AlphaFold predicts the protein folding basically, which is used for understanding the function of protein. So I was listening to a panel discussion, 2 Nobel laureate, one in chemistry, one in biologist. One was biologist and the other was Demis Hassabis. That time Demis Hassabis didn't get the Nobel Prize. So in that particular panel discussion, Demis, the chemist and the biologist, both are Nobel laureate. They were saying that AlphaFold is, without that, we could not possibly do anything right now. What we are doing is possible because of Demis. So then Demis said, what I did. There are maybe millions and millions possibilities of a particular fold. And if you do the experiments in lab, chemistry and biology, it will take maybe thousands of years to identify a particular protein or the structure of that protein. But through AI, what I did, I reduced the search space so that the search is simple. Now, maybe in 10 years, you will be able to discover, say, 1,000 proteins, which otherwise would have taken thousands of years. So that was very good for science, of course. And now he is into drug discovery also. Basically, he was the CEO of DeepMind, you know, and he got the Nobel Prize this year. I'm very happy, but the chemists are not happy. They said that now the computer scientists are getting into our domain and they are getting Nobel Prize. And similarly, physicists are not happy because Geoffrey Hinton got the Nobel Prize this year. Okay. That is another interesting thing. I am also following this guy for a long time, Acemoglu. He is in MIT, he's an economist. And this time in economics, Acemoglu and Johnson, they got the Nobel Prize. For what? Their long-time contribution. But they have a recent book which is called Power and Progress. So it was a very interesting book. It talks about the future of AI. So I'm just quoting a line from that. Technological innovations' impact on human welfare depends crucially on social choices about how these innovations are used. That means there are innovations which are very powerful, that how we use that is very important. And for that, actually, I was also listening to maybe a lecture that was given by Geoffrey Hinton, it was Royal Society or somewhere 15 days ago. And what he was saying is very scary. He was saying, I thought that at least AI will not be able to mimic consciousness. They will not be able to reach maybe as long as I am alive, I am happy. After that, whatever happens, I don't care. But Geoffrey Hinton was saying, those who are thinking that artificial intelligence cannot catch up the biological intelligence, they are in a fool's paradise. I'm telling you that in a few years, the subjective feeling AI can generate. So that was really scary. And he was also telling an interesting story. He was saying he was invited in China to give a lecture. And the Chinese people actually asked the PPTs before they allow you to give the lecture. Geoffrey Hinton sent it. He said, I intentionally removed the name of Chinese Prime Minister as bad actors. There were 3 names, Trump, Xi, and Putin. He said, I intentionally removed his name and sent it to the Chinese guys. They came back to me, you have to remove Putin's name also. So only Trump's name is there. So he was saying that if it is in the hand of bad actors, they can misuse it, and that could be dangerous for a human being. So I don't know what will happen and how the way AI is progressing. It's too fast to track, and where it will go in 5-10 years, nobody knows. Possibly people like Geoffrey Hinton can predict. So I hope eventually it will do good to humanity. Thank you so much.
Thank you, sir, for inaugural talk. So now we have lunch break, but before that we have a group photo. So please assemble fast outside for the group photo. Yeah. So we will start at around 1:45.
think it's not. Fine. So what is word level language identification? It is to identify the languages of individual words within a given text. And we know that there are a lot of work on high resource language like English and all. So in the under resource languages like Tulu, Kannada, etc., there are very less explored due to the lack of annotated data. And we have Dravidian languages, which consist different languages such as Tamil, Kannada, Tamil, Tulu, and Malayalam. So these languages are characteristic by unique morphological structures and a significant linguistic variation. So that demand specialized computational methodologies beyond our traditional NLP. So in the context of Dravidian languages, what we have done, like code mixing is often involves alternating between English and our regional language. So the objective of this task is like we are trying to invite the researchers to develop models capable of classifying words in a code mixed text involving Dravidian languages. So the task description. So here what we have done, like this is the extension of previous two editions. At the beginning, what we have done, we started with the Koli Sangeet, that is Kannada English, and then we worked on Tulu language, that is, so we have named it as Koli Sangeet. So then this is our third edition, that is Koli Dravidian. And so to work on this task, we have scrapped code mix YouTube comments in 4 different Dravidian languages, Tamil, Kannada, Malayalam, and Tulu. So these comments are pre-processed by removing punctuations and control characters, and then we have tokenized these into words. So afterward, the comments are romanized using Living library. So whatever we have done, that data set, it is annotated by the respective native speakers of the respective languages, as well as those who are fluent in English. And everything, the data set is manually annotated for the task. And so in this like task, we have data set comprises of different classes. We have language classes, that is Tamil, Kannada, Malayalam, Tulu, as well as English. Then we have a number, we have name, we have location, and mixed, if it is mixed with, Kannada English, Tulu English, or Tamil English, like that. So then and the data set is actually imbalanced. I'll show the figure. So this is the statistics of the Koli Dravidian data set, and we it's obviously we are collecting data from different summits. So at the time, what happened? We got imbalanced data. So in Tamil language, we have a large amount of Tamil data words, and for Kannada, we got English. And for Malayalam, we got 11,233 Malayalam words, and for Tulu, 11,649. Okay. So this is the samples which we got. There are a lot of, but I have taken save of them. So for each, in our data set, we have a word and corresponding tag. So for Tamil, we have used TM, and for English, like that. So these are the different samples that I have shown here. Then, so in this task, we have used macro average F1 score, and as well as weighted average F1 score. So actually the rank is based on macro average F1 score. Then as a baseline, what we have done, we have used 3 different machine learning models, like support vector machine, decision tree, and logistic regression. Then these are the results which we got for each language. Rank list of Tamil and Kannada language, and this is the rank list of Malayalam and Tulu languages. So whatever results we got,
from the participants. So these are the 4 participants which they got a good result. So 37 teams registered for this task, and 10 teams, 10 different 10 teams from different countries like India, Iran, Denmark, and various types of institutions like universities, research center, and industry. They have sent their prediction to our Chetas, and there are different types of approaches are worked on here, like ML, transfer learning, DLNR, and so among 10 teams, 8 teams submitted their working notes, and top performing was for Kannada, they have used Mudir, and for Malayalam and Tulu language, they got that Macha model. Then for Tamil, they have used voting classifier with the LRDT and SPM ML model. And these are the rest of the teams. And as I told, there are a lot of people who have worked on the machine learning than deep learning and transfer learning. Okay. So the conclusion is here is we need more work on Dravidian languages as well as word level language identification. And actually, we are the first, our team, we developed this Kannada and Tulu data set for word level language identification. After that, I think only one team who is working on Kannada and Tulu word level language identification. And we are trying to develop Telugu language also. Like I think in the upcoming Chetas, we will include that Telugu data set also. So these are the references, and thank you.
Any questions there? Identification experts. Okay, not then. Thank you for time reason, for time of sake of time, we move on. Thank you very much. All right. And we move to the next. You'll say, I think is next. Information retrieval for software engineering, right? Srijoni is coming. Excellent. Thank you. This track is also running also for quite some time now already. Yeah. 30 already. Ah, okay. Yeah, so quite nice. And please, we're happy to hear your talk.
Working? Thank you so much, Thomas, for introducing me. Hello, everyone. So here today we have the third version for the IRC track. It's information retrieval and software engineering. And before I actually start with this track, so I need to actually acknowledge people who came up with this idea of having a lecture with information retrieval and software engineering. And most of the credit goes to my professor, Pasha Pudingar from IIT Both and Professor Paul Law and Professor Devoshi Sanya. For the first time, they came in and they told me, okay, you can actually have something related to information retrieval and software engineering when we talk about metadata in software engineering. And this year, we actually joined forces with the lab of Devashi Ganguly and June Kalisi from the University of Glasgow, and they've actually come up with very interesting insights of how we actually can augment large language models into the code generation or the code quality prediction capabilities of LLM various LLM models. So now to understand what we are trying to do, so software engineering might be a bit vague initially because I faced this problem myself while doing a PhD. The people did ask me many questions related to, do you actually try to make new waterfall type of models? No, we don't. So we actually mine code. We try to understand how your code is behaving. The most important thing what we do here is, can we actually understand how legacy code works? Software maintenance is one of the largest challenge people are actually facing, the companies, even the research centers everywhere, because it's increasing exponentially, because it's I think it's from a personal experience. So if you actually are giving us code which you don't know, just to read and understand and do some edit, then it's quite difficult. And we're talking about legacy code. We're talking about code using C++ and COBOL, and this is running. People don't want to touch it because it's running. It's on that system. They don't want to touch it. You have to go and do edit within it. So that becomes a huge challenge. And that is where our research comes into picture, where we're trying to declutter code, make the comments more useful, improve the code generation, augment it with proper code whenever the code is not code is dirty or there are some code smell. So that's how we're trying to integrate the whole of IR and software engineering perspective into the actual software maintenance problem. So this is a mapping which we can review slide, which my professor will kill me if I do this. Okay. Fine, but still, I mean, just to understand what people have done across, I mean, 2021 was another point he's going to kill me because he wants papers for 2024, but still fine, if you compare with him on that. So what we are trying to come up is that these are the type of work which have been done, but now what you see here is mostly code search in the recent years. Debuggers, can we actually make more efficient debuggers? Debuggers we can converse with you. Can we actually augment GDB with more support for coming up with multi-service support? All these things are prevalent nowadays. Along with that, application domain. Now, this is an important one. Why? Because application domain here means what actually you write in the comment. Like, okay, this part of the code is for this part of the UI, or does this task. So everything related to the code which you cannot write or express in the code needs to be enclosed in a comment or a metadata. So our task is based on that. So we have two sets of tasks this year. The first task is the one which is running for 2 years. So what we try to do is that we try to use code comment. I mean, the code snippet and a comment. Can we actually find out the usefulness of the comments to understand that code, understand the legacy code? And this time we actually came up with another dimension to it, that, okay, can we actually use large language models to scale up this process? And the second task has been proposed by the software engineering team at University of Glasgow, where they are trying to understand code quality estimation. So what they're trying to, like, if you have many codes which can be generated for a problem task, how relevant those codes are to the actual problem. So this relevance would be mostly in terms of functional correctness. Are we able, is large language model able to, mark the code based on functional correctness, or does it have its own interpretation? So that's where research area which we are focusing on. So quickly, maybe I'll just go through these very quickly. Now, what type of features are we talking about? So we are talking about code and we are talking about comments. Both of these are two different granularities, but we convert them into a single granularity using word vectors. So word vectors related to code search, word vectors related to software engineering. So there are lots of word vectors which are prevalent. Code work, for example. So we can actually strip off some of the punctuation, make the code into a string of meaningful entities, hard to combine, and try to find out the relatedness. This is one of the features people have actually used in the past. Apart from that, we can also have linguistic features, trying to understand how big the comments are, how many stop words does it have, how many adverbs, verbs, nouns. It actually is not related to the code. Something which is different from the code, which can help us understand the code. So these are some of the knowledge graph-based features which we have used. Now, this is the end result for this year's task. So in total, there have been 14 submissions, and this is for task 1 first. So what we see is that what type of data, accuracy we have got. So the whole task here, we have to understand that we have given them a feed data with code and comments. They have tried to come up with a machine learning model to that is how useful the comment is. On top of that, a very big important factor here is, like, if we are trying to generate that this comment is good for a code, we need human annotators. So we did that for 16,000 comments as part of the research we conducted with Python code. But that involved going to companies for months, talking to developers, taking their giving the ground truth. So there is when large language models happen, like everyone, we also wanted to play along with it. So what we understood is, can we actually scale up the ground truth? Can we actually add more data? If we give a code and comments there to the large language model, then tell us if it's useful or not. So what if we try to generate such synthetic, like a single standard ground truth, augment it with the gold standard and see what type of, accuracy we get. So what we see here is that not much change, but yes, the overfitting is reduced. So that's one significant observation which we have. It's not that it's going to improve the accuracy to a larger extent, either that it decreases. It is stable in terms of at least the, the bias value straight up with the bit balance, and overfitting obviously reduces. And also what we see here for the task two, where actually the human drive data set is unique, and where there's a like two significant things in ID characters are actually come up with a score using large language models. So I'm giving you a problem statement, and these are the set of codes which are more relevant. And that has been evaluated using NDCG metrics and based on functional correctness, because you have the test cases. Like for every code, the test cases actually told us that okay, whether the code runs or not, and whether large language models interpret or not. This is why we have trying to figure in, can we use LLM for code quality generation, estimation? Can we use LLM for estimating the quality of code metadata? So it's like overall the quality prediction capabilities of large language models. Some of the interesting algorithms which participants have used. Basically, what we see here for in terms of binary classification, because it's either useful or not useful. So people have actually gone directly into transformer and BERT, but that didn't mean that we get very good results or extremely transforming results. But we have a good mix, because that's what our task was, to understand and analyze how these algorithms also behave. Because we don't want to analyze a black box never, because it doesn't work for code. We need to understand how each of these algorithms work with the data and come up with the predictions. Some of the pre-trained vectors which have been used, the large range of code-related vectors which have been used. In a nutshell, we could actually evaluate LLM capabilities in terms of code metadata as well as code generation quality estimation. And this is the outcome from the previous rounds of analysis, and we have been able to curate till now 9,500 data sets along with the two tracks which we had over the past 2 years. So this gets added on to the original 16,000 data sets we have, and we have released it, and we're also planning it to put into the data center at Super University, so that we can use more worldwide with a much more from the industry as well as from the research background. Thank you. I do have questions for you. Yeah.
Questions on the software? What was the average length of the software and snippets of the documents? Okay.
Yes, had a fight, but that's a problem with C, and that's why some of the embeddings which we generated was based particularly on C structures better results, because we were trying to combine BERT with Elmo, because we wanted to have the subword architecture as well as character level embeddings together. So that's the problem with C. That's how.
So your character level embedding was really a good problem here. Okay. Yeah. Any further question? Not the case. Okay, then thank you again, and you're very welcome. And for sake of time, we move on with our discussion, and we move to the sarcasm detection for Dravidian languages. And you will present, yeah. Shipria, yeah. Shipria will be presenting, and very interesting track now, very relevant, I think. Yeah, we have this such interesting complex tasks here at please.
Good afternoon to one and all present here. I'm Shri Priya, who's from SSN College of Engineering from Tamil Nadu. I am here to present the overview presentation of the shared task conducted on the title Sarcasm Identification of Dravidian Languages in Dravidian Code Mix Data. The organizers, we are the set of organizers who conducted this event. Myself and two other organizers are here who has joined in this conference. And the primary, the most important person, we would like to, I think it is Dr. Bardiraja from University of Galway. So he is the person who has laid the seed for this shared task, who has initiated this, and then we are doing it consecutively for the second year. So we have a we received very good response from participants, and they have submitted their systems, and they have participated in this event. So consecutively this year also we have conducted this event. The agenda of the presentation goes this way by introducing, what is sarcasm? What is the need for identifying the sarcasm in the online content? Then what is the task that we have proposed and then given to the participants? What is the data set that we have shared with the participants? And what methodologies that the teams have come up with, which is going to give a short overview of what submissions have been given, and the results and the discussions, what results, and then all the participants have been ranked, and then what is the conclusion of this task. So this is the overview or the agenda of the presentation. So basically, sarcasm is nothing but a linguistic expression that has been often used, where it is going to convey the opposite meaning of what is actually conveyed in terms of words. So we may be saying it with positive words, but internally the meaning is a negative opinion that is being conveyed. Say, for example, somebody has come up with a very bad idea. Oh, wow, that's a great idea. So that kind of sarcasm, but they're using all positive set of words, but they are conveying a negative feeling or a negative opinion that is being conveyed. So it is a bit easier for human beings to identify it, but it is by computers, it is going to be very difficult because it is using a lot of positive words. So it is very difficult for identifying the sarcasm in that. So what is the need or necessity for identifying the sarcasm? The necessity is that, so a lot of, social users, social media platform users have become humongous now. So everybody is communicating in social media. So the opinions and the communications are huge, wherein if the sarcasm is going to be there, sarcasm, if it is not being properly identified, then it becomes crucial for some of the important tasks like sentiment analysis and emotion recognition. I would like to just highlight upon what is sentiment analysis. Sentiment analysis is something like we are trying to identify the sentiment of the users based on any product. Say, for example, some product reviews have been given, or some film reviews, or some reviews that have been, or some information that has been shared about the politicians. So suppose if you take the product reviews, whether the product review is going to be a positive review or not. So based on that, it can have an impact. If the product owner is able to identify what is the how many positive reviews have been given by the in the public, how many positive reviews have been given by the public, if they are going to get that information, it's going to have a significant impact on their business. And similarly, it's going to have some significant impact on the politicians also, if they are going to make some comments. So if the sentiments are being identified properly, it has a lot of applications. But if sarcastic comments are going to be there, identifying the sentiment becomes very complex. So we are, very much interested in identifying or classifying whether a comment is an naturally positive or a sarcastic or a non-sarcastic one. So that's what is the primary objective of the shared task. So the challenge is what we have taken is to identify the sarcasm in code mix data. Code mix is, a lot of work has already happened in identifying sarcasm and doing sentiment analysis in English language, where we have a lot of resources that are already available, a lot of work has already been done. But the low resource languages, we don't have much resources that are available. So doing any task in a low resource language itself is a challenging one. However, we do have, this code mix data, because normally people, the users who chat on the social media don't stick on to one particular language, either English or a regional language. Normally, they try to chat in English, introducing some their own mother tongue or regional languages. So that has become very common nowadays. So, code mix are doing any kind of NLP task within the social media. The challenge mainly is to handle the code mix data. So that's what is a task that we have taken, is to identify the sarcasm in the code mix data, and then preferably we are doing it in Dravidian languages. So 2 Dravidian languages we have taken. One is English mixed with Tamil, and another subtask is English mixed with Malayalam. So 2 subtask we actually gave to the participants. So, and then the task is to, they were given the YouTube comments, and they were asked to identify whether they are sarcastic or non-sarcastic. It's basically a classification that they were asked to do. So the data set that we have collected by collecting the YouTube video comments, and then those comments are, some examples are being given for us to realize what kind of data is actually present in the data set that we have shared. Some data set, which is some samples that have been given for sarcastic and non-sarcastic. So the data set actually contain the training, validation, and test set. The distribution of the data that we have shared is here. So for Tamil English, we totally had some around 42,244 samples were there. And out of that, something very notable here is that sarcastic, it is around 11,000, and non-sarcastic samples were around 30,000. So similarly, when you look at the Malayalam, so we have around 3,000 samples for the sarcastic, and non-sarcastic is around 15,000. So the data set is basically skewed. So when we collected the data set, we didn't have much of samples for sarcasm as equivalent to the non-sarcastic samples. So this is one of the challenges that the participants have to take care while they are developing the systems. So the methodologies, we are very happy to share that there are around 23 participants for this task. Last year, when we conducted, there were around 11 teams who participated. So this year, it has increased to around 23 participants. And the submissions, were mainly using, I'm just summarizing what methodologies that they have adopted in their proposed systems. Starting from the very basic feature extractions like your TF, IDF, or bag of words, or even very simple features have been extracted, and they have employed machine learning classifier like logistic regression or a naive-based classifier or MLP, simple MLP. So they have used that, and they have come up with the results. So that is one thing. And there were some teams who have proposed, let me just show you. So there are some teams who have used deep learning techniques. So mainly they have used the transformer-based methodologies to do the contextual embeddings, to get the contextual embeddings, so which could better capture the pre-trained models. We're able to give good representations, which are the contextual representations of the data, and using that they were classifying it, and then that gave very good results. So this is one thing. And there were some submissions which were based on using the RNN, recurrent neural networks, mainly your LSTM, especially the bidirectional LSTM they have used, and along with some classifier like convolution neural networks, they have come up with some models, and that also has yielded good results. And I mean, yet another observation is that since the data set was skewed, some of them have applied some data augmentation techniques to populate the data for the minority data set, and the minority class is your sarcasm class. So they have applied like SMOT or any other some augmentation techniques they have used to populate data on the minority class, and they have used, and that has significantly increased the results. That's what they have given in the models that they have shared, the paper that they have shared. So I have just given a glance of, I mean, all the work that has been presented by all the 23 teams. So the conclusion, or what is the observation, is that around out of the 23 teams, all the teams were evaluated based on the macro F1 score. We have chosen it because it's going to be the harmonic mean of both your precision and recall. So F1 score has been used, and then it was observed that the top score was 0.74 for the Tamil English. Tamil English, it is going to be 0.74. So it is very good to observe that 6 teams have achieved that score. 6 teams were using different methodologies, but still they were able to achieve the same score of 0.74. And for the Malayalam English task, I mean, the score was around 0.76 was the top score. So the very common observation that we could see is that, so the transformer-based language models were showing remarkable capabilities of capturing the context, and then doing some kind of augmentation that has helped them to improve the results. That's what is the overall conclusion or the observation that we have come up with. So these are the results. So as I said, so we have the 6 teams which are ranking first. So in the Tamil English task, so the other teams, 2 teams have got second rank, and then it goes this way. And for Malayalam English, this is one participant who has got, 0.76. This is a participant from, so this is about participant. What I would like to say is this is the participant who has got 0.76 as the first score in Malayalam English. The same person has got 0.74 and who's also securing the first place in Tamil English also. So this team is from Mexico. So we are very happy that we got one participant from Mexico, and they have even won both the subtasks, achieving 0.74 and 0.6 in both the tasks. So to summarize, we have conducted this sarcasm identification task for the 2 Dravidian languages, that is Tamil English and Malayalam English. And 23 participants have participated in this. And there were 6 teams who got the first prize and the first rank in Tamil English. And out of that, this team, UMNSH NLP team, who is from Mexico, they have got the first rank, and they have also achieved the same first rank in the Malayalam English also, achieving 0.76. So this is, we are very happy and proud to say that this is the first shared task that has been conducted on the sarcasm identification. And we are consecutively conducting this for the 2nd year. Thank you.
Thank you for this. You have 23 teams, very, very good.
Yeah,
Excellent.
okay.
Any questions? Yeah.
Was that real data, or was that something that is simulated?
No, sir. The data was actually downloaded from the YouTube. Comments were reviews. Reviews were taken, and that was given. It was not simulated data. Yes, sir. It was, some examples also that I have given. So it was code mixed. Some were transliterated. some were given in the regional language itself, in Tamil itself, and some were having some English also mixed. So everything was there.
About quantity, can you say something about quantity?
Mostly it was transliterated. Tamil, I mean, if it is Tamil, it is going to be translated in English, and some were mixed with both English and Tamil, and some comments were in Tamil alone.
Oh,
Yeah, it was, I mean, equal mix of that.
Most is in Tamil and then some English is
Tamil
injected.
and Tamil, the transliterated one.
That's it. And
Yeah.
some English is injected.
Yeah.
Okay. So the dominating is in Tamil.
Yeah,
Very
English is there.
Any question? Yes, I have to ask one question because there's 23 teams and there's one more.
No, sir. The classification task normally, I mean, we use precision and recall, or F1 score is a very normal.
Categorizing as a sarcasm or sarcasm.
Yeah. We gave it to the YouTube comments were downloaded, and then we gave it to people who's in literature also, Tamil literature arts college is working, and then we have asked them to label it, whether they are sarcasm or not.
Should have some particular knowledge of the.
Yeah, definitely. I mean, we didn't do it from our side, so we gave it to people from the literature college, Tamil literature, who are doing Tamil literature.
Is there any other way, any other approach other than this? Because this is a resource. This is again the resource concern.
Yes, sir. Actually, and that's a good thing that because we didn't have the data set that is directly available, so it is one of the achievement that you have done, that we have created the data set and we have labeled it and created one. So we don't have, I mean, existing data set for this Tamil or Malayalam, for Dravidian languages. Yeah, since, I mean, we don't have the data set or the resources, so we have created it. But we have used people from Tamil, who are doing Tamil literature in the arts college, and we have asked them to label it.
Yeah.
Yeah.
So while you are basically measuring this performance, so have you checked the performance difference between the transliterated version and the non-transliterated version? Like where you have the proper Tamil script and then the English script, and where we have the Tamil part written in the English language and the, then formal English. So have you checked that? What is the
No, I mean, actually, I mean, since it is an task who's going to get the first rank, so we didn't go into the details of identifying how many were this, as you said, transliterated one or the Roman script or in English itself. So we didn't do, I mean, such classification in doing the evaluation.
So one of the things I was wondering is that this task is kind of subjective, right? The example that you put forward over there, that, okay, this is a good idea or a great idea. Now that may be, in fact, be true, right? The speaker could be actually appreciating the idea.
Yeah.
But we humans, you said that humans are good at figuring out what's sarcasm and what's not. But then it usually depends on the context in some way.
Definitely.
Right? And without the context, if you are using annotators to annotate something, but they don't have the context, right? To have the context, they have to watch the whole video maybe, or maybe like go through all the comments in the context just to gain some context of that particular sentence or the document that they're annotating, right? So is that something that they were told to do? Like when they're annotating a particular comment, like read the previous comments just to gain some context and maybe watch the video as well. Was that a part of the instruction?
That's a good question. Like even when we saw some examples, that example was like, since we don't know the previous knowledge about it, so we were, I mean, puzzled whether to target as sarcastic or non-sarcastic. Yeah, absolutely. But something, I mean, not all the comments were having such an issue. In some places, I mean, they were giving a comment with smiley or emoticon that was giving, so that gives an information. In some places, I mean, they are giving some information at the beginning and then they are saying it, that is fine. So I mean, I could understand that the question is like, when it is very simple and simple comment, so from which you are not able to figure out from the, but that requires the previous knowledge. Most of the comments were the comments about the movies. So people who were able to target, I mean, they had the idea about the movies, so they were able to easily do it. So there were few things that were there. So, but since it was movie reviews, most of them were aware of it.
One question I have to ask, because it was 23 participants and we have seen all the tracks and all the research now is on large language models, and in the methods used, I didn't see zero shot or learning. So
yeah, there is one
other model, right?
Yes.
Why is that? It doesn't do are they not working good for sarcasm, or are they not good for Dravidian languages?
I mean, actually, I'm not very sure about, I mean, what they have used, but the idea that they have used is, I mean, zero shot learning. But what, I mean, challenges that they faced, I'm not very much aware of it.
You had such a nice overview of the method, so it was really interesting that this would not nobody use. Oh, great! Thank you very much.
Thank you. Thank you for the opportunity.
And with that, we move on to different sessions, right? Peer review selected papers, and the first session will be chaired by Debasis.
Good to see you. I'm the session chair. Okay, so is this working? Anyway. All right. Yeah, so welcome to the conference track of FIRE. So till now we have been going through the shared tasks where you participate in a task, you submit runs, and then you either talk about the overview of the task or you share your approach. Now this one is a bit different because here there is a call for peer-reviewed submissions, just like any standard conference on IR or any other field. And then, it's all reviewed work, and you tend to, publish novel work in this conference track. So we have 4 presentations now. And the first one is going to be by, it's a weighted retrieval model for large collections under the exceedance over relevant extremes by Dipannita. So just before she starts, just want to confirm if all the speakers are here, or do we need to switch to online mode? So the next talk is going to be by Shubhankar. You are here, okay. The next is by Devendra.
Sorry, we are in online, presenting by Prasanna.
And how are you going to, do you have that arrangement here, the online thing? Okay, great.
Yeah, I can share it, yes.
And the 4th one is by Amay. Is that also online? Is the speaker here? Oh, it says online. Okay, anyway. So yeah. Dipannita.
Okay, so good afternoon, everyone. So today I am presenting our work, a weighted retrieval model for large collection under the exceedance over relevant extreme. So before going to the main work, I am just explaining something, which is that we have observed this paper basically follows an observation which was shown in that truncated models for probability weighted retrieval model papers. So here in that paper, the authors show that in the real world large collections, there are some terms are present with excessive high frequency. So as we know that in the TF-IDF based or in the probabilistic retrieval models, basically the term frequencies are used to estimate the saliency of a term in a document. Since IDF is used for all the terms in a collection, so mainly the thing is that the TF part is the major component which actually plays the key role in estimating the relevance score. So what happens in large collection when if some in non-relevant documents, if some terms are present with very higher normalized term frequency, so that documents score will be overestimated by the traditional models. So I will go into the background of this analysis. So the authors basically take the a set of query. So these are the pointer. Excuse me. Pointer is not working. Mouse. Okay. So the authors basically take a set of query, and these are the collections, and these are the relevant documents of these queries. So what the author did, they basically at first they take the normalized term frequency in the relevant documents and take the maximum of it, which is MNTF T1 RQ1 and MNTF T3 RQ3, which is T1, T3 and T6 are the terms present in the query 1. Similarly, they take the maximum of the terms present in the query 2, T2, T3, T4 and similarly for query 3. So after that, they take the maximum TF of in each collection. So in the collection, there are total 9 documents. So they take the normalized term frequencies of the terms of T1 to T6 and take their maximum value and show it in the MNTF T1 T6 in this way. So in this way, they basically take all the MNTF for all the 6 terms. So in this, after that, they finally get a set which is MC, which has the maximum normalized term frequency of the collections, and MR, which is the maximum normalized term frequency of the terms in the relevant documents. So using this set of this set, they first plot this a bar chart where they observe that the mean of MR and MC are they are showing. So they observe that in the large collection such as Kluwer, there are first of all for almost every term the collection MNTF is many higher than the term of the relevant documents, and the number of documents where the maximum normalized term frequency in the collection greater than maximum normalized term frequency is in the relevant documents are almost 1.9 million documents. So this for these documents, the non-relevant documents basically get the higher score. So they get higher score by the traditional models, and the ranking list basically what we get is erroneous. So they propose to address this gap. They propose a model which is EXPT, where they basically use the TF function as a exponential function of normalized TFs and truncate them using a truncation parameter. So if this is the distribution of the normalized time frequency, and they estimate the truncation parameter using the training queries. Then after the truncation point, if some normalized time frequency values are there, they basically eliminate them from the ranked list. So they are make their contribution as 0. So what happened? The problem with this model is that it is heavily dependent on the estimation of this truncation parameter tau. So what will happen if the truncation parameter becomes very low? So many relevant documents may be get rejected and they won't appear in the ranked list, or if the choice of truncation parameter becomes very higher, so this will be similar as the normal model. So there will be no effect of this truncation value, this truncated model. And besides, also a model is proposed where they discount the information gain when a term appears multiple times. So what they did is that every time with every occurrence when the terms are appeared, so they basically penalize it. But the problem is this model also that they basically over penalizes the rare terms. Suppose a term is present in a document, suppose 3 to 4 times, these terms will also get penalized by this model. So to address this research gap, we have proposed the model. So at first, before going to the model, I am just describing the normalization term frequency normalization scheme that we have used, which is RITF, which basically normalizes the term frequency based on the average term frequency in a document, so that the term frequency are normalized based on how the other documents are present in the document, and they also normalize it using the length. So they transpose it and finally use this ranking function. So based on this normalization function, we not normalization scheme, so we work with RITF and LRTF. So what our proposed ranking function is that, so we basically try to estimate a value which is alpha t, which should be lower if the normalized time frequency is many maximum than the maximum of the MR, which is basically the maximum normalized term frequency of the terms present in the relevant documents. So we need to estimate this alpha value. So if a value which appear with very high normalized term frequency than MR, so their value will be lower. So we to address this, we basically calculate a probability that will estimate that that will provide the probability that an observed new term will exceed this values, or these are the relevant extremes. So if they, if a norm observed term xqt basically exceed this the distribution, so they are they will get a lower value, and if it will be in the middle part, so they will get a higher value. So to estimate the exceedance probability, so alpha t probability zt greater than xqt, so we need to estimate the probability of the CDF of MRs. So since our motivation is to estimate the probability value when the sample size will approach infinity, because we have the numbers for MRs, but we are saying that we may get a time frequency value when it will be many higher than MR. So we require the insight about when sample size approaches infinity. Beside also in the paper they have also observed that there are among these many of the high frequency terms, many are outlier. So outlier and tail related risk management extreme value theory is used. So we used Gumbel distribution to model the probability, that probability z given x. So as I have already said, we work on this two normalized term frequency, which is RITF, relative interdocument TF, and length regularized TF, LRTF. So we have basically two random variables x1 to xn, which represent LRTF, and another one is y1 to yn, which represent the RITFs of the relevance of the set of the query. So we need to estimate the maximum of this, which will be z1 and z2. So for this we use the Gumbel distribution. So this is the Gumbel distribution, and after that what will be the alpha t? So it will be alpha LRTF and alpha RITF, which will we will get from this equation. So in the Gumbel distribution there are four parameters: mu L, mu beta L, and mu R, beta R. So mu L, beta L for the LRTFs and mu R, beta R for the RITFs. So for the parameter estimation, this is the standard Gumbel distribution parameter estimation formula. So beta and mu are basically estimated using this formula, where this is the mean and standard deviation. So using a training set of query, training query set, we use a fivefold cross validation to estimate the beta value. But we have observed that when we use this formula of mu, the result we are getting is not appropriate. So we actually sometimes it getting good, sometimes it getting bad for different data sets. So we fix mu L and mu R as a hyperparameter and vary it from 500 to 200 for mu L, since the LRTF values are higher, and the mu R value is from 3 to 7 for each fold of CluWeb09A and CluWeb09B. So and finally chosen a value, we have observed that when the mu L value is greater than 110 and mu R greater than 5, so for all the data set we are getting a good amount of effective results. So this is our proposed final ranking function, which is TFF will be which will basically use from the MATF functions. So this is alpha LRTFs we estimate from the Gumbel distribution, and this is the exceedance probability that unobserved terms LRTF will exceed the relevant documents the maximum term frequency, and LRTF is the transport and TFF functions which the authors of truncated probabilistic model originally used, but they used exponential distribution and truncate them, but we keep it same and we use only the exponential distribution to transpose the original LRTF and RRTF value, and this is the final ranking function. So we experiment on the 3 data sets, ClueWeb 09A, 09B, and Million Query data set. So Million Query data set and ClueWeb 09B, these are all the same corpus. So we did not use estimate the value for Million Query 2009. We use the parameters what we have estimated from ClueWeb 09B to check the how the method is performing on Million Query 209. So we first remove the stop words and stem the word using Porter stemmer. And for ClueWeb 09N and ClueWeb 09B, we remove the spam documents using a Waterloo spam score of less than 70%. For indexing, we use the INRI search engine, and I have already told that we used 5-fold cross validation for ClueWeb 09A, 09B, and since the sparse judgment are available for Million Query 209, so 2009, so we remove the unjudged document from the rank list to produce the final result. So we compare it with the Dirichlet smooth language model BM25 with parameters, and MATF, which is where these normalization functions are first proposed, and the exponential truncated exponential distribution based probabilistic retrieval model. Okay, sir. So this is the result on ClueWeb 09A dataset. So here also we have seen that in the ClueWeb 09A dataset, from all the models, a language which are not basically truncate truncate any normalized term frequency values. So from this model, the proposed model is showing significantly good result. So for ClueWeb 09B also, we are getting that this model basically outperforms all these models. And for Million Query, though, they are showing a very good amount of improvement with significant difference in all the metrics. We also compare with the the truncated probabilistic model. Here also we have seen that the proposed retrieval model WER outperforms EXPT in ClueWeb 09B also, and in Million Query 2009 also. So what I have told that the problem with EXPT is that they basically heavily rely on the choice of truncation parameters. So I am showing that we actually varied the truncation parameter for LRTFs from 45 to 80, and we have observed that with the change of truncation parameter, the results are changing, where it is same for WER, no parameter, no hard rejection of any documents, or keeping the model as is not going in this WER. So we conclude that since this is not a neural model, does not require very much of computations, so we can use it as a first stage ranker, and it can effectively retrieve from large collection. So like the previous model, it does not hardly reject any relevant documents. So and it requires very small amount of data for parameter estimation, and it can be useful for large scale search. So thank you. Any questions?
Do you have questions for the speaker? Yes.
Yeah, hi. So this may sound like a very naive question. Like, can you share like what is the intuition behind applying this Gumbel distribution that you have mentioned?
Actually, we use, first of all, we use Gumbel distribution because it has been observed that the term frequency values basically follow the exponential distribution. So our thing is that we want to capture that when when the term frequency value in the relevant document uh, uh, will actually exceed. So what in the flood estimation kind of things are happen that when it will exceed some values, so they use Gumbel distribution. So we keeping in that mind, we first use the Gumbel distribution. That when it will basically exceed the observed value will exceed the training set or previously shown values.
Any more questions? I have one for you. So this is quite complex statistics that you described, right? I didn't follow much of that, but I have a very intuitive, simple question, right? The thing is, in the era of neural language models, where you can train. So I think the whole purpose is like to come up with a unique TF function that works better than the logarithmic function or any other standard ways, right? So if I can learn that function from data, why would I go and then like tweak? Because this involves a bit of tweaking. And then it also involves like having a number of queries on which you measure the statistics, right?
Number of we basically not number of queries is not, because we take 200 queries and 80-20.
Yes, but you're optimizing some parameters based on those queries, right?
Yes.
But the thing is that, okay, so the question I want, so yeah, this is an approach that doesn't require training. But then why didn't you evaluate that on TradeDale, which has got, I don't know, 800,000 queries in the training set? So it would have been better to tune the statistical parameters.
We have actually run the experiments on TradeDale, but we have observed that in TradeDale, that statistics that number of MC, the difference between MC and MR is not that much different. So when we run on TradeDale, we run on TradeDale and Gov2 also. So there we get almost same results. So our thing is that it's applicable when the collection is large and it has very spam documents and outliers are there. So clean documents, it basically provides the same as what basically the MATF provides.
Okay, so if there are no other questions, we can move forward to the next speaker. Thanks a lot again, speaker. So for some complex statistics, the next talk is going to be by Shubhankar, right? And his paper's title is Leveraging In-Context Learning and Retrieval Augmented Generation for Automatic Question Answering, right? Yeah. Oh, question generation. Right. Educational domains. Oh, the page is yours. Thank you.
Hello. Hi everyone. So my name is Shubhankar Maiti. So today I will be presenting our work leveraging in-context learning and retrieval augmented generation for automated question generation in educational domains. So as we all know that educational question generation is essential for personalized learning and assessment, but it remains time consuming and cognitively demanding for educators while creating or curating educational questions, which requires a balance between contextual relevance and pedagogical soundness. That is why automated question generation tools come into picture. However, many existing AQG systems produce out of context questions and reducing their effectiveness in educational applications. So in this work, we actually explored several advanced state-of-the-art techniques, for example, in context learning and retrieval augmented generation for promising solution for generating contextually relevant and high quality questions. And also we combine this ICL and RAG method into a hybrid model, which can address existing limitations, enabling more reliable and contextual automated question generation systems. So in this work, our contributions are as follows. So first, we have done a comparative analysis of ICL and RAG for automated question generation in educational domain. And after that, we evaluate how each method performs individually in generating questions from textbook passages on several school level subjects and assess their respective strengths and weaknesses. And after that, we combine this ICL and RAG into a hybrid model to generate high quality, contextually accurate and pedagogically aligned questions. And also our hybrid approaches leverages this ICL and RAG to guide the generation process. And after that, for the evaluation purposes, we have used several automated metrics and human evaluation metrics using expert educators. So for the automated metrics, we have used BROI4, RUGEL, Meteor, CHRF, BART score, which are used actually to compare the gold standard question with the generated question by the AQG systems. And as we have seen, there are few limitations in these matrices. For example, this BROI4, RUGEL, CHRF, BART score, these matrices generally actually compare the gold standard question with the generated question based on the longest common subsequence or n-gram based matching. That is why actually they don't capture the contextual meaning of the or contextual applicability of the generated question. That is why you also use some human evaluation metrics, for example, grammaticality, appropriateness, relevance, complexity, and answerability, which provides insight into pedagogical value of each approach. So here is the task definition in brief. So here the task of our AQG system can be formulated as follows. So given an input passage P, the objective is to generate a question Q which is relevant to the content of P, or P can be set as a context from which the question is being generated, which is contextually accurate and aligned with the educational goals. And here is the input-output representation. So you can see that there is a function FP equal to Q. So here F function can be think of the ICL model, RAG model, or the hybrid model which combines ICL and RAG. So the input to the model is a passage P or the context, which can be a sentence, a paragraph, or the longer text excerpt from the educational material or textbooks, for example, NCERT textbook. So in this work, we have used NCERT textbook for the experiments. The output is a question Q that is relevant to P and suitable for use in the educational setting. So here is the function FP equal to Q. And this is the brief explanation or task definition of the ICL. So in the ICL paradigm, given an input passage P new, so actually in the in-context learning, we already seen in the yesterday in the Nilanjan's talk that in the ICL, you have to give some examples to the large language model. So here we have used this P1, Q1, P2 up to PK and QK. So for that, here we have used K equal to 3, 5, 7, several few short examples to generate questions given a new passage or context. So here the equation which can be written as Q new equal to F ICL. So F ICL is a ICL model. So which takes P new means on the passage on which the new question will be generated, and this PI QI is the few short examples. So here we have used K equal to 3, 5, 7, etc. And it is the brief definition of the RAG method. So given a passage P, the model retrieves a set of relevant documents R1, R2, RK from an external corpus. For example, there are NCERT website from which we have used this RAG method. These documents provide an additional context, and the final question Q is generated as the following equation, which is Q equal to F RAG, and which takes P and Ri, I equal to K. So Ri is the retrieved documents from the NCERT website, and K is the number of documents which is retrieved. And here is the hybrid model. So this is the brief definition of the hybrid model. So we can see that here Q equal to F hybrid. So F hybrid is the hybrid model or the function which takes the P on which the new question would be generated, and Ri y I equal to 1 to K. So Ri I equal to 1 to K means there are K retrieved documents, and also the few short examples are there. Pi Qi I equal to 1 to M. So both the few short method and the RAG has been used for the hybrid model. And the data set. So the data set is the existing data set. So this paper has been published last year, FIRE 2023 from our side. So this data set actually contains several subjects, for example, history, geography, economics, environmental studies, and science. And the data set is curated from the NCERT textbooks for standards 6 to 12 and covering diverse chapters with varying segment lengths. And for our experiments, we extracted only the context and question, focusing on the evaluating how well the models generate questions based on the provided context or passages. So methodology, so I will discuss the methodology in brief. So for example, in ICL, we have used GPT-4 model to generate the question based on the few short prompt. And here the prompt is structured as follows. For example, there are P1, Q1, P2, Q2 up to PK, QK, and we have used K equal to 357. So P1 means the passage question like that. So K equal to 3 means 3 times we have used this P1, Q1, P2, Q2, P3, Q3, then P new, and we have, and the LLM have to just predict the new question from the passage like that. So for K equal to 3, 5, 5, and 7, we have used that. And for the RAG, we have utilizes the BART model as the generative backbone, and also use the FAS based retrieval module. So FAS actually stands for Facebook AI Research, AI Similarity Search, so which is a library which has been used for the actually for the searching purposes. So what it is doing is, for example, we just retrieved NCERT textbook from the websites, and after that it will create the embedding using sentence transformer, and it will store it, and this FAS will store these embeddings in a index format so that the retrieval would be easier. And after that, this retrieval module will actually retrieve, for example, if I say K equal to 3 or 5, then 5 retrieved 5 passage will be retrieved from the embeddings which are stored in the FAS. So for a given passage, here the retrieved module identifies the most relevant documents from the curated corpus, denoted as Ri equal to 1, I equal to 1 to K. And also we have fine-tuned this BART model on the EduProf so that during generation, the generated question is aligned with the context with the data set. And after that, so this is the equation we have seen before, and this is the hybrid model. So we have just combined those previous 2 methods in this hybrid model. So for the hybrid model, the retrieved documents are retrieved from the given passage P, and few short learning mechanism uses retrieved documents. So for that, we have used K equal to 5 and M equal to 5. And baseline model. So in the previous work, we have used only T5 large and BART large on this EduProf dataset, and no work has been done on this dataset. So that is why we have taken T5 large and the BART large as our baseline models. And these are the results. So this is the automatic evaluation results, which is BLOI4, RUGEL, Meteor, CHRF, and BART score. So I already discussed that this type of automated metrics just take the gold standard question and just do the similarity matching with the generated question by the AQG system based on the n-gram based matching or longest common subsequence based matching or BART embedding based similarity. So we can see that in case of ICL K equal to 7, it outperforms the other baseline models as well as RAG and hybrid model. So because ICL k equal to 7 actually shows the best performance, because I think this RAG and hybrid model sometimes retrieve some passages from the from the outside domain. For example, we use the NCERT website, and sometimes what it does is it retrieves some passages from the website which is not aligned to the passage given from which the question should be generated. That is why sometimes the generated question using RAG and hybrid model which is not aligned to the given passage on which the question need to be generated. That is why the similarity based matching score are quite low for this method RAG and hybrid model. But when we use in context learning, it means we have just showing some examples, for example 7 example, 5 example or 3 examples to the LLM, and we ask the LLM to generate a new question given a new passage, then it works better in terms of automated evaluation metrics. But when we see the human evaluation results, so for human evaluation results, what we have done is we have just appointed 5 educators, and they are asked to score the generated question based on several metrics, for example grammaticality, appropriateness, relevance, complexity of the question, and answerability of the question from the given context. Then we have seen that hybrid model actually outperforms other models including the baseline models. So actually it means that hybrid model actually generate more complex or more appropriate questions, but maybe the generated question sometimes not matching to the gold standard question. That is why the automated evaluation metrics scores are low, but human evaluation metrics scores are higher for the hybrid model. So here are some examples. For example, you can see that here is the example from the history subject. So there is a context and the gold standard question is there, and you can see that the previous baseline approaches, for example T5 large and BART large, for example this highlighted one is the question actually indicates the irrelevant or unanswerable question according to the context. So you can see that the generated question using BART large cannot be answered from this context, but when we use ICL, RAG or hybrid model, so these questions are somewhat aligned to the context or can be somewhat can be answered from the context. And also there is another example on economics. We can see that. So here you can see that the T5 large and BART large actually generate some questions which cannot be answered from the context again, but when we use ICL, RAG and hybrid model, the questions are more aligned to the context. So this is the conclusion. So the study investigated several methods, for example ICL, RAG and the hybrid model, and for ICL k equal to 7 excels in the automated metrics, and hybrid model k equal to 5, m equal to 5 outperforms the human evaluation matrices. And this hybrid model actually effectively combines the RAG and ICL, generating questions with greater depth and contextual alignment, surpassing the baseline models like T5 large and BART large. But we haven't integrated feedbacks from the educators while generating questions. We haven't integrated feedback from the students on the generated questions. So in the future, we are actually looking forward to do that. And also we want to use several cutting edge LLMs, for example, Gemini, Llama 270 billion, like that. Thank you.
Wonderful talk. Thank you. Do you have questions for the speaker?
Yes, sir. Really nice presentation. I have just few questions, right? So, like I didn't see in the results, like you haven't mentioned about the 0 shot results, or even 1 shot or 2 shot. Like, how did you come up with like 3, 5, 7?
Yeah, actually we have actually explored 0 shot, 1 shot, 2 shot, like that, but we haven't seen much improvement from 2 shot. For example, we have used k equal to 3, 5, 7. So also we have used 0, 1, 2, but we haven't seen much improvement on 0, 1, 2 than 3. That is why you also just so the improvement or the change in the generating question are most significant in 3, 5, 7. So 0, 1, 2, for example, the generated question using k equal to 5 is somewhat similar to k equal to 4. That is why we haven't included in the paper or the results.
Okay, I think that should be like an ablation that could be
Okay.
present in the presentation, then will be much more clear that how much improvement you are getting from that zero shot, right?
Okay, okay.
Else, how would you know that
Okay.
how much improvement you are getting? Okay. Another thing is like I didn't see the prompts that you use because with these models, the prompts are very much important. How you pose the question to the model.
So you have actually, I included so you can see that the general structure of the ICL prompts is as follows. So actually the prompts is just the passage and the generated question from the passage like that.
Yeah, actually, like you have attended the tutorial last day, right?
Yeah.
There were, in some cases, there were some things that we call as the system prompt.
Yeah.
Then we have the examples, then we have the actual test,
Yeah.
right? So was there any structure provided to these models? Did you use any kind of API or directly you just like how did you use the things? So that is missing, like the experiment part. So if you are using an API,
Yeah, yeah.
you have
Obviously, we have
to-
used API for large language models. So we have used API. So we have paid
in the
API. We have used. Yeah.
In the API, like you have to provide that system.
Yeah,
prompt.
yeah.
So there is a part that that mentions the
Prompt
system
is in quotation. Yes, sir.
Exactly.
Yeah.
So that is
So in quotation, we have given that the prompt, so the context and the question like that. So prompt question for example, k equal to 3, the examples will be 3 examples like that pairs, and after that there are new passage and the question should be generated on that.
Yeah, I think that's
okay.
Any other questions? Quick one. Maybe I have a quick question. So the idea is quite fascinating, right? Now I guess that what you are calling ICL is like with labeled examples.
Yeah.
And RAG is without labeled data.
Yeah, yeah.
That's why you are having two names. Right?
Yes, yes. Okay.
So thanks, the speaker again.
Thank you.
Okay, so the next talk is going to be online, and who is going to the speaker? Devendra. So is he connected on Zoom? Okay.
Yeah. Can you hear me?
Yes, we can. Yeah.
Yeah, okay. So I will share my screen now.
Yeah, try sharing your screen and then if that works.
I think someone is sharing this, so I can't able to share my screen. Yeah, let me.
Okay, so you have about 15 minutes of time. So whenever you
Yeah.
are
Thank you. Is my screen is visible, right?
Yes, yes, it is.
Yep. Thank you. Okay. Yeah. Good afternoon to all. Thank you for this opportunity to present here in the FIRE conference. And so our topic is about the constructive learning enhancement BERT models for hate speech detection in Marathi and Telugu language, which are all low resource language in Indic language families. And the authors are from IIT Kharagpur and Digital University of Kerala and University of Galway as well. So the last two authors are the supervisor for this for us, which are Paul Bettler and Dr. Bharadiraja Chakravarti. And I am Prasanna Kumar Kumaresan. I am a PhD student, second year in Data Science Institute, University of Galway, Ireland. So in this presentation, we are gonna go through the outline of introduction of the problem. So hate speech against the LGBTQ of particularly for the homosexual and transgender peoples, and the problem statement of those particular hate speech for the Indic languages which are low resourced, and some of the literature review of some of the papers, and then the methodology part what we have find out to find the hate speech against the LGBTQ, and then the result sections which are we got the results from the methodology set, and then the final part is our conclusions of the our research work. So introduction is about the global connectivity and challenges, which is social media platforms or several global hubs to interaction between each users through online, where they can able to share their own content or any reviews or any um, uh, interviews or any other movie videos content jokes, whatever, games. So a lot of content available in the various social media platforms, but we are specifically focused on the YouTube comments, because where they can able to put all the content together and as a long video. So we choose those YouTube platform to collect our data. And for this is the worldwide to share insights for the information and express their opinions. However, this increased connectivity being unique challenges, such as the spread of harmful content like hate speech. Particularly we focused on the LGBTQ, which we particular among which we particular focused in the LGBTQ is homosexual and transgender people, which is named as homophobia and transphobia, and the positive aspects of these platforms. And the second one is like balancing free speech and regulation, which is this when we are facing the social media platforms, which is the difficult task of balancing the expressions of regular harmful behaviors. So while they promote open dialogue and the exchange of ideas, they must also prevent the escalations of harassment and abusive comments, particularly against the each communities. And we target specific targets of the gender minorities, which is, as I already mentioned, which is target LGBTQ individuals or any communities who faces the higher risk of online harassments and mental health issues. And these addressing issues is mitigate psychological harm and promote equality in digital space. So the problem statement of this work is about hate speech in low resource Indic languages, because there are very less resources for the particular Indian subcontinent languages. For example, Tamil, Malayalam, Kannada, Telugu, Marathi, and Gujarati, and everything. So these are the low resource languages among Indian culture. There are several more, but this particularly for the Marathi and Telugu language. And this hate speech, especially targeting vulnerable group like LGBTQ community, it's prevalent in social media. Detecting it in the resource languages such as Marathi and Telugu poses significant challenges due to limited linguistic resources and annotated data sets. So need for enhancement learning technique. There is a pressing need for advanced technique like contrastive learning to adopt pre-trained models for specific tasks, like hate speech directions. This approach enables models to better capture context and improve accuracy of hate speech directions among the homophobia and transphobia from the YouTube comments. So this focused on the LGBTQ hate speech directions, as I already mentioned about that, particularly hate speech on homosexual and transgender people, which is named as homophobia and transphobia. These data were collected from the YouTube, and which are targeted as LGBTQ individuals or any communities. And detecting such hate speech requires tailored systems that address the unique linguistics and societal nonsense or commands for Marathi and Telugu languages. The challenges in real world implementation, which deploying hate speech detection system in real world environment involves addressing issues like data set bias, scalability, and generalizability. These systems must be reliable and effective in diverse and dynamic online context. So why we choose specific area of hate speech is like there are several hate speech against all the normal toxic content, as well as the other offensive or abusive languages. But we first while coming to a specific part of India, they have several hate speech against the LGBTQ peoples. There are specific words to hate them, even that can be able to harm themselves. So we focused that for that. So while that we go through some of the literature review papers. So they have performed, many of them have performed machine learning and basic pre-trained transformer models, and even now they are coming up with the LLM language models for the speech of particular LGBTQ communities to make this safer online. So the first paper that about the homophobia and transphobia detection for Hindi and Malayalam, and even they have uh, directed for the other three languages, which are Tamil, English, and code mixed of Tamil English, which is written in the Roman scripts. So they have performed a specific language fast text and TF-IDF embeddings for their text data for as a future extractions with the ML models, and which got the higher accuracy in the SVM and random forest methods. Even the multilingual BERT model also performed the better accuracies. And the second one, they have used CBOW feature extraction method with the decision tree for the hate speech of Twitter data. And the other paper or performed POS taggings and multi-layer perceptron with the logistic regressions to find out in the Twitter data. And the last one about the POS tagging, which kind of a span extractions things, is a kind of NER methods, and they have used an ABS classifier to identify the Italian data benchmarks, and they have conducted the HODI chat task as well. So we source and this is about the data sets. We source the data sets from our organizer as our supervisor, Bhardiraj Chakravarti, who organized the homophobia and transphobia detection in social media comments at LTEDI workshop, which is language technology, equality, diversity, and inclusion, which is during in EACL 2024 this year, and I am the one of the organizer of as well. So we gather data from there as only the Marathi and Telugu languages. There are several. They collected 10 languages from the Indian subcontinents as well as the English and Spanish as well. But we specifically focused on Marathi and Telugu, and the Telugu dataset has 9,000 training, around 9,000 training instances, and 1,000 development and 1,900 test sets. Even for Marathi, they have 1,300 training instances, and both test and development have 750 commands. So these data sets are like each commands which it's in the single line of sentence, which doesn't have any multiple line of sentences. So we specifically focused on YouTube because of this reason. When we are coming for an Instagram or any other social media platform, we can't able to get the one line of single sentences, because if we find out any single word or one or two words for the commands, that can't able to identify the hate speech against target of LGBTQ peoples. And also we have performed the data augmentation technique, because there are some issues behind the data sets. So we know online augmentations were used. Only the online on-fly augmentation technique, which is back translation, were used for generating positive samples for each data point in the constructive loss. So the figure shows that the data splits in each languages, and each training sets, each sets of each language, and their distributions are written in the top of the bar. So we coming up to the methodology, which is encoder model, which are all pre-trained transformer models or pre-trained language models, which is specifically trained on Marathi and Telugu data sets. We have performed two sets of, we choose the two sets of models, which is BERT and Robota model, which is trained on specifically for the Marathi and Telugu, which is BERT and Telugu BERT, and even Robota Telugu and Robota Marathi for both the methodologies. And we fine-tuned this approach with the all with the 10 epochs with the layer of encoder models with unfrozen, which is like one by one until the final epoch. So by the conclusion of the training after the 10th epoch, so they out of 10 out of 12 attention layers were unfrozen, so that we can get the better accuracy and better results for detecting the hate speech of LGBTQ communities. And so this diagram, which shows the overall methodology using the back translation, BERT encoder, and constructive loss, where we have used here. So this is our methodology part, where we have to where we build implemented for finding the hate speech against LGBTQ community for the specifically for Marathi and Telugu BERT, Telugu dataset. So there the constructive learning. So why we choose constructive learning technique, because of which is one of the particular powerful technique which in the machine learning platform, especially used for the contextual of NLP of hate speech detection, as we discussed in this presentation. So That's why, and also it can able to enhance the future discriminations are effective in the scenarios. Even it can be able to improve the generalization and utilize the unlabeled data as well. So this is the reason why we use the particular of constructive learning. So in this constructive learning, we have selected two constructive losses, which is supervised constructive learning, which mentioned as subcon, and dual constructive learning as dual CL method. So this kind subcon and dual allows for effective adaptations of pre-trained BERT models and robota model for two specific commands and the challenges of hate speech detection in the specific Marathi and Telugu languages. So this method is not only enhance the accuracies and reliability of the model, but also ensures that they are sensitive to the specific culture and contextual commands necessary for the effective detection of hate speech in these languages. And the combined there are some formulas that I have given here, and the final, which is combined loss function, which is total equal to lambda star constructive and supervised learning, which is indicate that the constructive learning loss, and with the supervised learning loss functions, which can be it's which with the L constructive is typically a loss designed to increase the distance between the dissimilar samples and decrease the distance between the similar samples as well in the future space of the method. And the supervised L supervised method step, it's any traditional supervised loss such as the cross entropy of classification talks has been performed there, and the lambda was performed as the hyperparameter that balance the conditions contributions of constructive loss and supervised loss functions. So here are the results for Marathi datasets. We performed eight methodology, which is with the MagaBird, which has like first we performed zero shot learning and normal MagaBird, how it's got to be performed with the accuracy of 68%, and we combined the constructive loss function as both the subcon and dual CL constructive loss functions in the MagaBird methodology, and it got the higher accuracy, which is 70%. And even when compared to the robota performed very well in the supervised constructive learning function, which is 71.09 accuracy. So this fine-tuning performance, the models are fine-tuned on the training data sets where they evaluated on the test sets, which is MagaBird fine-tuned with the subcon achieved the highest overall performance accuracy of 70%. And then the Telugu for the Telugu data sets, 90, it's above gone through 90 because of there are augmented data set as well, and also we have the around 10,000 commands for each each language. So that's why we got about 90 percentage of results in Telugu Bird plus subcon constructive learning loss functions. So final stage of presentation is like conclusion, which is significant of the study. This research focused on addressing the critical issues of detecting homophobia and transphobia in low resource languages, which is in Indian subcontinent, specifically for Marathi and Telugu, mostly targeted in the YouTube comments. It's emphasized the importance of creating safer online space by using advanced NLP technique tailored to underrepresented the languages, and the best performing models and results, which are we used MagaBird and Telugu Bird. Maga Robota and Telugu Robota, both the models are performed very well in each languages, and they got 90% and 70% in MagaBird, and 90% in Telugu. And for the broader implication, this research contributes to combining online hate speech targeting to the LGBTQ individuals in diverse linguistic contexts. So the proposed methods that can assess the platform moderate and get the positive to the LGBTQ community in identifying and addressing the toxic languages from the social media platforms. And the future directions is like, while we resulting all the promising, there is no room for improvement. So we will focusing on enhancing performance through domain specific feature engineering, and also we will specific focused on the context of those specific spanned content of the LGBT spanned content of the homophobia and transphobia comments from the YouTube. So there are some of the references that were given, and this work has been conducted with the financial support of SFI Center of Research Training on Artificial Intelligence, and also the CRTAI, which is Centered Research Training for Artificial Intelligence, and School of Computer Science, University of Galway. Thank you.
Yes, thanks, the speaker.
Thank you.
The speaker is online, I believe, right? Would you be prepared to answer questions?
Yeah, I can try. Yes.
Is there any question for the speaker from the room? Okay, I guess there are no questions.
Thank you.
So,
So in this presentation, I have given the my LinkedIn profile. If you want to connect, you can connect to me. Yeah. Thank you
right.
for all the
I just want to ask
opportunities.
you one question.
Yeah.
You can go back to your results slides. Yes, somewhere here, right? So
Yeah.
these are all BART-based models that you have experimented with. Is that correct?
Yes.
Did you try to use large language models as well? I mean, BART is an encoder-only model, but then
Yeah.
try to use something like either an encoder-decoder based model like T5 or like a decoder-only model like GPT. Would that also work in these kind of tasks? What do you think?
Yeah, it will work, but we haven't tried with the TF and GPT as you said, and we are working with the T5 model for the specific of NER method, which is finding the homophobia and transphobia span detection, which is specific part of context of the hate speech. We are working on that, and we will try to improve, as you said, as with these LLM models.
Okay, that's wonderful.
Yeah.
There's a question. Maybe it's easier if you just come over here and ask the question. Yeah, so it will be good.
Am I audible?
Yeah.
I think you have used the BERT model, and if suppose I'm wrong, please correct me. The thing is, BERT model is can able to. I mean, it has been trained with English language alone. So it means that it's only vocabulary of English, and how you supposed to execute your regional languages.
So basically, BERT model is not the specific for English languages, because there are multilingual as well, which is trained on 100 plus languages. Even for Robota is, as you said, it's in English, but there are specific trained languages out there, which we use. Just Marathi Robota model is specifically trained for the Marathi languages, and for the Telugu Robota is also there for the hate speech detections.
That's it. So you are you are used XML Roberta for the instead of Roberta, and MBERT as instead of BERT.
Yeah. So no. So basically, there are both ways is there, which is, as you said, there is. I didn't use like MBERT instead of BERT model. There is a specific trained method for the Marathi language is there. So for example, is that we used here is Marathi BERT model, so which is particularly trained on Marathi languages, so not then the other language, which is particularly trained for, like as you said, it's English, it's particularly trained for the Marathi one and also for the Telugu one. So there are specific trained one is there, so we use those for the constructive learning method.
If you are fine-tuned, I mean, you know, how is the parameters you have included any other extra parameters in this BERT model?
The author is not there, so he knows the what are the parameters what he used, but basically the normal parameter we have used, and we fine-tuned with the epochs and unfrozen method.
You are frozen and executed. Okay. And number of vocabularies in this case, how may know it?
No, I don't know how many vocabularies have been here. I didn't check it out.
Regional, so maybe increase of vocabulary. That's why.
Okay, we'll check it out. Thank you for the questions, and I will check out with this.
Yeah, I think that's actually a very good
Thank
question.
you.
the number of byte pair encodings and the number of tokens can actually affect your training. So yeah,
Mm.
maybe you should just go and check your model, like what's the vocabulary size and all that. It was a very good
Yeah,
talk.
sure.
So I don't
Thank
think
you.
there are any further questions. Thanks for the talk, Devendra.
Sorry, it's me, Prasanna.
Oh, sorry.
It's okay. Thank you. Thank you for all the opportunities.
Thank you. Thanks a
Yeah.
lot. Okay, so with that, we have one remaining talk, but the speaker is not here. We are going to play the video, okay? But we can go and have our coffee because we don't want to get delayed further. So you can listen to the recording at any some other time, or you can like bring your coffee over here if you are interested. But we won't be able to ask questions to the speaker because he's not here, right? So with that, we break for the coffee and then we come back at what time exactly, Vargo? At 4 o'clock. Okay, so we come back here at 4 o'clock. Video clear. Video clear.
बंद कर
Greetings of the day. My name is Madhushri Wagh and I am here with my co-authors Mayur, Amay, Pawan and our mentor Raviraj Joshi sir to present a paper on importance of layer pruning for smaller BERT models and low resource languages. Our paper ID is 60. Moving on, the agenda of today's presentation is that I would start by going through the background, then we will look at the problem statement and I would discuss the objectives. Background. Background refers to the past research that has been done in this field. Research has been done on transformer-based models like BERT, which stands for Bidirectional Encoder Representation from Transformers, and it has revolutionized NLP. It helps in tasks such as classification and text generation. However, it poses challenges for low resource languages and low resource tracks because despite the success of BERT, it has large model size and computational demands. It limits their deployment for languages like Marathi because Marathi has limited training data. The solution that we have come up for this problem is model compression techniques, particularly layer pruning. Layer pruning refers to removal of redundant layers and lowering the computational costs without compromising the performance. The problem statement overall is transformer-based models are too large and resource intensive for low-resource languages like Marathi. Multilingual models like BERT often struggle with language-specific tasks, whereas training smaller models from scratch demands similar or significant resources. This creates a need for efficient methods like layer pruning, as we are doing in our project, to optimize the large models for resource constrained settings without sacrificing the performance. Now, the objectives are our primary goal is to develop optimized smaller versions of BERT and Mural for Marathi language classification tasks using layer pruning strategies. The key focus areas are evaluating the effectiveness of pruning strategies. We are performing top pruning, middle pruning, and bottom pruning to maintain high accuracy across data sets of varying lengths. The data sets we are using are HHC, LPC, and LDC, and comparing pruned models to scratch-trained smaller compact variants like Mahabert Small. Key contributions. Key contributions include developing of efficient models, layer pruning with fine tuning yields high performance, And optimal strategies, middle layer pruning. We observe that middle layer pruning balances efficiency and accuracy the best compared to top and bottom layer pruning. Then we do model comparisons. Monolingual models outperform multilingual ones, and pruned models outperform the scratch-trained compact models. We are trying to develop a scalable approach, a cost-effective method for adapting advanced NLP models in low resource tracks. Related work has been done in CNN pruning techniques, transformer-based pruning, and indic NLP research. In CNN pruning techniques, weight pruning, structured pruning, feature representation-based pruning reduces complexity. In transformer-based model pruning, techniques like layer drop includes dropping of layers during training without fine-tuning, and methods like quantization and knowledge distillation have been used to reduce memory and reduce computational costs. And indic NLP research includes Mural, which stands for multilingual multilingual representation of Indian languages, which has been pre-trained on 17 Indian languages, and XLMR show promise for cross-lingual transfer, but it underperforms low resource tasks, while Mahabert outperforms them.
So let's begin by looking at the models and datasets that we have used. For this study, we have used these models. First is Mahabert V2. Mahabert is a Marathi BERT model with 12 transformer layers. It is a multilingual BERT model which is fine-tuned on L3 Cube Mahacorpus and other publicly available Marathi monolingual datasets. Next is Google Mural. It is also a multilingual BERT model with 12 transformer layers, and it is fine-tuned on Marathi and other Indic languages. Next is Mahabert Small. Mahabert Small is a smaller version of Marathi BERT model with 6 transformer layers. Next is Mahabert Smaller. It is also a smaller version of Marathi BERT model with 2 transformer layers. Next, let's look at the datasets that we are using to train these models. We have used L3 Cube's Indic News Marathi dataset. L3 Cube Indic News Marathi is a long, medium, and short document classification dataset in Marathi. This dataset is based on news articles and headlines. So it consists of these datasets. First is short headline classification, that is SHC. This dataset is consisting of the headlines of news articles paired with their respective categorical labels. Example, crime, education, fashion, health, etc. This dataset evaluates the model's performance on short text. Next is long paragraph classification, that is LPC. In this dataset, each record contains a sub-article of news with its respective categorical label. And this dataset measures the performance of medium length content. Next is LDC, that is long document classification. This dataset contains records having entire news articles with its corresponding categorical label. In the table, you can see the number of articles for each dataset and their distribution for trained, test, and validation dataset. So in total, there are 27,525 articles for each of the dataset. Now let's discuss the various pruning strategies that we are using. So the layer pruning involves selectively removing the transformer layers to make the model smaller and more efficient while retaining their accuracy. So we have focused on 3 strategies. First is top layer pruning. So top layer pruning removes the top layers of the model. Middle layer pruning removes the middle layers of the model, and bottom layer pruning removes the bottom layers of the models. So in this diagram, you can see the original model which has 12 layers. Then top 6 layers are pruned, middle 6 layers are pruned, and bottom 6 layers are pruned. Similarly, top 10 layers are pruned, middle 10 layers are pruned, and bottom 10 layers are pruned. So there are 6 combinations that we are using to prune the models, and we are training all these pruned models on the 3 data sets: SHC, LDC, and LPC. Next, I will walk you through the experiments where we evaluated these strategies and compared them with our baseline and compact models. So our experiments were designed to comprehensively evaluate the performance of pruned and compact models. So the models that we used are MahaBERT V2, Google Mural, MahaBERT Small, and MahaBERT Small. Then datasets that we are using are SHC, LPC, LDC to ensure that we capture a range of text lengths and complexities. Next, the pruning strategies. We are using 3 pruning strategies: top, middle, and bottom layer prune. Now the evaluation metrics. We have used 2 key metrics for evaluation. First is accuracy, where we compare the validation and test accuracy across all the datasets and model combinations. Next metric is efficiency, where we measure the reduction in model size and computational complexity that is required. Finally, we compare the pruned models against their unpruned baseline models to evaluate the performance and compare the accuracies. So this helped us to identify the best strategies to balance efficiency with accuracy.
We will be continuing with results and discussion in the further slides. This slide contains the result table. The table presents the results of pruning strategies applied to MahaBERT V2 and Google Mural models on the 3 Marathi datasets: SHC, LPC, and LDC. Various pruning configurations such as top 6, middle 6, and bottom 6 layers, as well as top 10, middle 10, and bottom 10 layers were tested to assess their impact on model performance. The results highlight the importance of carefully selecting pruning strategies as they significantly affect the accuracy and efficiency of the models across different datasets. Results of Marathi SHC dataset. MahaBERT V2 achieved its highest accuracy of 92.18% with top 6 layers pruned, and middle 6 layers pruning provides 90.8% accuracy. Pruning bottom 6 layers in MahaBERT V2 gives 89.35% accuracy, while top 10 layers pruning drops to 89.2% accuracy. Middle 10 layers pruning improves to 92% accuracy, making it the best configuration. Google Mural performs best with middle 6 layers pruned at 90.69% accuracy, followed by top 6 layers at 89.08% accuracy. As more layers are pruned in Google Mural, accuracy slightly declines, but it remains competitive. MahaBERT V2 benefits most on the middle layer pruning, while Google Mural favors fewer middle layer prunes. Results of Marathi LPC dataset. MahaBERT V2 achieves its highest accuracy of 91.05% accuracy with middle 6 layers pruning, followed closely by bottom 6 layers at 90.04% accuracy. Top 6 layers pruning for MahaBERT V2 results in 90.33% accuracy, indicating minimal performance impact when top layers are pruned. Google Mural performs best with middle 6 layers pruned at 90.37% accuracy, followed by bottom 6 layers at 89.7% accuracy. Top 6 layers pruning lowers performance to 88.92% accuracy. Overall, middle layer pruning yields the highest accuracy for the most of the models on Marathi LPC dataset. Results of Marathi LDC dataset. MahaBERT V2 achieves its highest accuracy of 91.05% with middle 6 layers pruning, followed by top 6 layers at 90.47% accuracy and bottom 6 layer at 90.04% accuracy. Google Mural performed best with bottom 6 layers pruned reaching 90.11% accuracy, while middle 6 layers pruning provides 89.70% accuracy. Pruning the top 6 layers for Google Mural results in lower accuracy of 87.62% accuracy, indicating this may not be ideal for the LDC dataset. These results suggest Mahabhat V2 is effective with middle layer pruning, while Google Mural benefits most from pruning the bottom layers. From the previous slide, we can gather an overview that the experimental results indicate no single pruning strategy consistently outperforms other across all models and dataset. Different pruning strategy excel in different model and dataset combination, reflecting the complexity of optimizing BERT models. However, pruning from the middle layers generally provides a balanced trade-off between model size reduction and performance retention, often achieving scores competitive with top and bottom pruning strategies. The main highlighted discussion points are as follows. Under performance size trade-off, pruning the middle layers showed the best balance. The approach reduces model size while keeping key low and high level features, making it efficient and accurate. For monolingual versus multilingual models, we found that Mahabhat V2 designed specifically for Marathi consistently outperformed Google Mural. This suggests monolingual models can be more effective for language-specific tasks. Finally, practical benefits. Layer pruning makes it easier to deploy NLP models in resource-limited settings without needing to train smaller models from scratch, which improves accessibility and efficiency. In short, middle layer pruning is efficient. Monolingual models excel for specific languages, and pruning supports practical deployment. From our research, we can gather the following conclusions that middle layer pruning effectively optimizes BERT model, preserving accuracy and reducing computational load. This approach can make BERT model more accessible for low resource languages and limited resource environments. Future research might explore dynamic pruning or extend these findings to other low resource languages. In short, middle layer pruning offers a practical, efficient path for deploying NLP in resource constrained settings. Thank you. We end our presentation.
Okay, so
With last presentation, we are completing with the today's conference track paper. Now we are moving to the track track working notes or maybe track presentation. So first, I am starting as I started in the morning, like so. This track is spoken query cross-lingual information retrieval for Indian language, and we have only one presentation. Spoken query retrieval in monolingual context with Whisper and SBOT model. So this will be presented by Prabhu and Levin. Okay, so you have a 3 to 4 minutes for presentation and then questions.
Good evening, all. Am I audible? Right. Yeah. So actually, we are trying to present here the spoken query language for the monolingual only. That is not the cross-lingual cases, first of all. And we are used. I mean, since it is spoken query, we planned like to translate that particular text. I mean, spoken content to the text. So for that case, we are used this Whisper model, which also a transformer architecture. And we are used a 6 layer of transfer architecture. So it's very lightweighted architecture. And another thing is that both the result and value of the text content just transfer, I mean, convert to the embedded with the help of SBOT. So the challenges.
So what are the challenges in the spoken query retrieval is that first the conversion between the spoken query to the text queries. So there are other methods in which you can use the multimodal models, which can embed the text and both into the same embedding space, but it's quite costly in the terms of creating those embeddings using those multimodal models. So what we ended up doing is we converted that spoken query into text and then embedded that text using a smaller text-only models to create the embeddings for that.
So the speech recognition model we are used. I already mentioned it's a Whisper model we are used, and this open source model, and it also supports of course universal language. It supports English language too, so that's why I used it. And then I use this base model only in this Whisper, which is having about 74 millions of parameters to execute. So there is about 6 layers I showed. So it's all encoded, decoder based model, which converts that spoken content to the text content. And so I just did small statistical analysis from the spoken content. The spoken content is about the length of maximum duration is about 9 seconds. So out of this, most of the spoken contents will be range from 2 seconds to 3 seconds range. And that I just highlighted with the color of red, which is the training their spoken content, and their pale green is for the text content. And most of the most frequent contents are lies only in 2 second duration. However, what are the durations? I'm right now not use this duration because I just use the pre-trained model only. So it just convert to the equivalent text content only. So I just focus only on the embedding part of the text only. So this number is right now I'm not making much relevant for us right now. So the workflow of the spoken query.
Yeah. So from the text corpus that is provided from the FHIR dataset, we extracted it and created the embeddings with the so using the CentOS transformer, we created embeddings for the corresponding thing and also for the embeddings for the spoken queries that are there using the same model. So we created this we stored this embedding into a Parquet file in a corresponding to with this document ID and also this query embeddings with the ID. And then we compared this using this dense retrieval. What we did is we compared this query embeddings with the document embeddings using cosine similarity and retrieve the documents based on the cosine similarity. And we did the evaluation using the training and testing things for this.
So additionally, I would like to add that actually, I told you that it's a sentence embedded model, BERT model I'm used. So the model that produce output called SBOT, 384 dimension of each vector. And out of this, I just that feature I just along with it, the last feature as usual I just use the label of the corresponding label as a corresponding document ID, and that document name is encoded, and I convert. So finally, my total embedded content is about 4 lakhs times of 385 dimensions. So with that, we have start our finding the similarity of with the queries and the corresponding matrices. So this is the result we have obtained, and the testing queries result, which is already showed in the morning slide itself. And we have evaluated the same thing in the training queries also. Our score is just very low, and the terms of MAP is MAP is mean average precision from the retrieved documents of about 0.03, and MMR score is 0.14, and a recall of up to 100 and up to 1000. With the increase of that number of document size, I am getting the maximum recall is of 0.31 as a result. So these are the form matrices equations.
You can skip.
Sir,
You may skip
yeah,
the.
So I just want to emphasize this is what we are tried. So to check whether why is there, I mean how the matrices is evaluated. So I just make the the measuring of that matrices with every 50 documents, including of every 50 documents. So I understood that my percentages keep on reducing, which is not giving much better relevance. So I actually personally concluding that instead of this particular SBIRD model with a base level, right? Instead of that, maybe I can include with a higher model like BERT's normal base model itself. So that's what I would like to conclude it. So these are
yeah. So to improve this performance of this thing, so I think we think that this model may not be able to rank this properly because it's a base model and we didn't do any fine tuning on this model. So upon doing fine tuning, the performance may increase for this domain specific task. So these are the feature works that we are planning to do.
So any questions and feedback?
Thoughts, how you fine tune?
So the amount of data is actually limited. So the only 50 queries are there. So the fine tuning will be on basic classification tasks. So given the embeddings, what we are planning to do is a simple classifier model that can takes in our simple classifier model can be also trained. So using these embeddings and the corresponding relevance, but binary classification model can be trained on top of the thing, or else the whole model and additional layer can be binary classifier may attached to that, and the whole model can be fine-tuned for a binary classification task.
So one thing, we have a fire corpus.
Yeah.
Fire corpus have a every year 50 queries. The total
Okay.
200 queries we have.
Okay.
So I used only the current
Yeah,
year of
that is
corpus
spoken
of-
query, but text query we have 200.
Okay.
Okay. So
I'll just try with that particular case.
yeah. Okay.
So any questions?
So yeah.
Thank you all.
So now we have a next track presentation, that is CodeMix information retrieval. So session chair is Supriya.
So today I will present Retrieve GPT, Margin Prompts and Mathematical Models for Enhanced Code Mix Information Retrieval by Aniket and Subham. Hello. Yeah, so I am presenting Retrieve GPT, Margin Prompts and Mathematical Models for Enhanced Code Mix Information Retrieval by Aniket and Subham. So the task here is that we are given code mixed Bengali with English language text, and we are given queries and documents, and we have to find which query is relevant to which document. So that is the task, and the challenge is the nature of the code mix text and the multilingual and informal nature of the code mix text. So that is the challenge, and handling that challenge, we use GPT 3.5 Turbo via prompting along with the sequential nature of relevant documents to frame a mathematical approach which helps to detect relevant documents to a query. Coming to the dataset part, they have given us more than 1 lakh documents in the training set and 25 queries in the training set. The testing set had 30 queries, and the dataset was in Roman translated Bengali mixed with English language. Coming to the task definition, the task is to automatically determine the relevance of a query to a document within the code mix text, focusing on English and Roman translated Bengali. Given a query, the goal is to classify whether a query is relevant or not relevant to a document. So so basically we used a prompting approach via GPT 3.5. So there were main 4 reasons why we use this approach. First one is handling ambiguity and contextual nuances, enhanced language understanding, adaptability to informal and unstructured text, and reduction of noise and irrelevance. So this is our approach. We gave a prompt to the model, GPT 3.5 Turbo model, given the query and the document, find how relevant is the query to the document, and then provide a relevance score between 0 and 1. And then we fed that into a mathematical framework. By using the mathematical framework, we're trying to target the sequential nature of documents. So if we go into the data set that was given to us, the data set, there was sequential presence of relevant documents. So corresponding to a particular query, there was sequential presence of relevant documents and then again non-relevant documents. So our mathematical approach is trying to capture that after the score given by the GPT 3.5 Turbo model. So this is the GPT 3.5 Turbo architecture model where the input is provided in the form of a prompt and the output is a relevance score. And then the relevance score is fed into the mathematical framework to get a probability score. So this equation reflects that. So this is basically the explanation of the mathematical equation given here. So these are the results that we got. So we got a MAP score of more than 0.7, and we ran the model from a temperature value of 0.5 to 0.9. So 0.5, 0.6, 0.7, 0.8, and 0.9, and these are the scores. So this work contributes to enhancing information accessibility in marginalized communities, underscoring the potential of advanced AI models in bridging communication gaps in diverse linguistic landscape. We observe that GPT 3.5 Turbo model, along with the mathematical formulation approach, performs well for the task of code mixed information retrieval, though there is scope for improvement. Thank you. Any questions?
Question? So what happened if the documents not in the sequence order?
So what we observed manually is that when the training set was given to us, when there are sequential documents, it is able to capture well. So suppose for a particular document, there are 100, suppose for a particular query, there are 100 documents which are given. So suppose from 0.20 to 0.40, they are highly relevant, suppose in the training set. So for capturing that, we use the threshold function. So above 0.3, if it is trying to push that value. If the previous one is relevant, when trying to push that, the next one is a higher probability of being there. That is what we're trying to capture. But that point that you are trying to say, that if there are like not, but they are not
the sequence
distributed,
order,
not
like-
sequence order, that there is a higher chance that it will not be captured by our model. So that is where we need to maybe improve.
Okay. Because when we collect the data, it's on the sequence order, but in general, maybe.
In general, yes. But since it was that situation was there in your data, so we tried to use this framework. Thank you.
So I think Aditya will. Aditya, are you there?
Yes, yes. Am I audible?
Okay, okay. Yeah, you can start.
Okay, I'll share my screen. Do I need to open my video also? Switch on my video also?
Yes, if possible.
Okay, yeah. I hope I'm visible. Okay, so I'll start. So, hi everyone. My name is Aditya Sharma. Sorry, my health is a bit low today, so that's why my voice is not well today. Okay, so the topic of my paper is Infotext CM. So I'm addressing the problem of code mix data retrieval by using the approach of text classification. So first we'll have a little background of the why code mix information retrieval. So because of growing popularity of social media and other digital platforms, the uh, the thing of this code mix thing is getting popular. So people are mixing two or more languages in a single text or sentence. But there is a lack of resources and tools for processing these code mix text. So the main challenges are challenges are, first is language identification. So that means we have to identify which language that a particular word belongs to. For example, main thing is transliteration. So people usually write a second language in another language. For example, people write, on social media, people write Bengali, Hindi, or something in English form, using English text, English vocabulary. So, for example, if someone writes tin, tin means Bengali, 3 in Bengali. But if we look at tin from English perspective, it means metal container in English. So if someone had used tin in a sentence, so it for a model to make sure that this tin belongs to Bengali or English is challenging. Another thing is the syntactic diversity between the languages. The grammatical and morphological complexity of languages is different, and especially if there are low source languages, for example Bengali, Marathi. For these languages, the problem of code mix information retrieval becomes more challenging. Next, we'll have a look at the problem that we try to address is to create an information retrieval model that is capable of handling those queries which has not been previously seen by the model. So we have a set of documents, a few set of queries, and we have some relevance score on this. Based of this relevance score, we want to rank our documents on the so that the relevance of a query to a particular document can be seen. So we want to rank the documents in the relevance to a query in descending order of the relevance scores. Then we have a look at the dataset. So the provided dataset was in a multilingual the languages used were Bengali and English, code mixed Bengali and English languages. And for training purposes, we were provided with 20 queries. And additionally, there was a document that had human annotated annotated values, like which shows that a particular query is for particular query, which of the document is relevant to a particular query, and number of test queries were 30. So in total, we had around 107900 documents, and these are some additional statistics about the dataset. So I worked on few approaches on this. I looked at this code mixed information retrieval problem from few perspectives. First, I tried to implement some pre-processing. What is the effect of few pre-processing approaches? For example, stop word removal and stemming on the retrieval accuracy. And then we did the ranking, re-ranking of pre-trained with pre-trained models, language models. And then the third approach was to perform ranking of documents based on the fine-tuned sentence BERT model. And fourth approach was to re-rank the SBERT rankings using graph neural network models. So this is the overall framework. So initially we had documents and queries. First thing we did was to perform pre-processing, and after pre-processing we had cleaned documents and cleaned queries. This were fed into sorry.
You have a 2-minute remaining.
Okay, so yeah, I'll wrap up quickly. So fed into BERT-based model, and for re-ranking, this were fed into a graph neural network for final document ranking. So first process was to remove the stop words. So for this, I implemented 4 types of these libraries: NLTK, Terrier, Smart, and custom library from this paper. These are the results for all the pre-processing techniques we implemented. Out of all these, the custom library that was built of that paper was performed very well. Next is to re-rank traditional models using pre-trained language model. So we implemented 4 different SBERT models for performing the re-ranking of these of the results obtained from the traditional models. So out of these, we chose the best performing model from here, the previous approach. So these are the results from these pre-trained models. There is no fine-tuning yet. Next is to fine-tune the SBERT model using these using the data provided. So initially the queries and documents were fed into SBERT model for generating the embeddings, and then the an evaluator, an inbuilt evaluator was used to fine tune this model. Information retrieval evaluator was used to fine tune this model. So we noticed that one thing we noticed that from previous approach, for few models the performance decreases. This might be due to the reason that the initial model was trained in different language, and we tried it to fine tune on code mixed English and Bengali language, and this might have caused some confusion in the model. Next was to re-rank the results from SBERT. So we performed re-ranking by using a GNN model, so that we can leverage the graph structure form of the data. So this approach was motivated by the potential that GNNs are able to capture more complex relationships and interactions within the data. But to our disappointment, this model, GNN based model, did not perform as well. So in conclusion, we address the problem of word mix information retrieval of Bengali and language. We explored the performance of various techniques on various pre-processing techniques for Bengali and English information retrieval. We saw that transformer-based, fine-tuned transformer-based approaches are good at very good at showed good retrieval performance. That's all from my side.
Okay. Thank you.
Yeah. Thank you. Thank you very much.
Any question? Oh, okay. No question. So now we have a last track overview. That is from the Italy. Personalized information retrieval by the Marco and Pranav. So Pranav and Marco, are you there?
Yeah, I'm Marco and I'm there. I'm here.
Yeah. So you can start your screen sharing.
Okay, thank you.
Yeah. So if possible, complete it within 10 to 15 minutes.
Okay, can you see the presentation?
Yes, your presentation is visible.
Okay. Okay, so hello to everyone. I'm Marco Braga. I'm a PhD student in the University of Milano Bicocca in Italy, and I will present you our track for FIRE, that is personalized information retrieval, that we as a group organized for this 2024. So here there's just an overview of the presentation. So there will be an introduction, and then I will tackle all the tasks, the evaluation, participation, and so on. So just what is personalization in information retrieval? Personalized search is one of the main development of information retrieval, and the aim of personalized search is to provide results that can better fit the user needs or preferences. And so personalization can improve the user perceived quality of the service. But there are some issues related to the dataset, that to the published dataset, that are not suited for evaluating personalization from a user perspective. There are some public dataset, but they have a problem issues related to the anonymity of the user. So for this reason, first we create a dataset for personalized question answering, and we collected the question and answer from Stack Exchange, which is a popular community question answering platform, and you can see here that for each user who wrote a question, then you can see two answers written by different users, and each answer has a related score that in this example is 16 or 18. And then the user who wrote the question can also mark one answer as the best one. So in this way, we have a indirect, we can say an indirect, it's an indirect way to obtain labeled data directly from users. And that's why we call this personalized retrieval, because the aim sorry, the aim of the model is to select the best answer, the one selected by the user, from the pool of past answers. Here there is just a overview of the dataset. We collect the data from 50 different communities in Stack Exchange. From 2008 to 2022, and the results are more than 1 million questions and 2 million answers provided by more than 100,000 users. Here just you can see the structure of the dataset. So for each question, user and answer, we have different information related to the user, like the account, the reputation, and the view. And for the question, we have also not only the title and the body, but also the tags. And the tags is the one of the most important information for us for doing personalization. Here there are some other statistics related to the dataset. So for example, how much question we have and how much answers also we have. The splitting between training, validation, and test are done temporarily to avoid any kind of data leakage. And so in the end, we have like more than 100,000 training question, 70,000 validation question, and 99,000 test question. Okay. Now I will focus more on the task. We propose two different tasks. The first one, we call it standard information retrieval, because the idea is to tackle the problem of personalized information retrieval using some classical approaches for information retrieval. So we have the question of the that is considered as the query. The answer are the collection of the document from which the answer will be retrieved. As I just told you before, personalization can be tackled using any novel technique to create a user profile, and we decided to use this using the tags related to the query. Some other possible approaches are BM25, two-stage ranking, or using also BERT-like or MonoT5 models. The second task instead is a prompt-based information retrieval. And so the idea is to ask to large language models such as GPT if a question is related, if an answer can be the question to a related, so if a document can be an answer for a related question, giving also in the prompt some user-related information, so a user profile that can be, for example, also the list of tags of questions that the user wrote, or other question or documents in general, we can say that the user wrote. For the evaluation for both tasks, we use traditional evaluation metrics such as precision, recall, mean average precision, mean reciprocal ranking, and NDCG. Sorry. We receive more than 15 registration to the tasks, to both of the tasks. But at the end, we received only 2 brands and 2 papers, and we decided to accept 1 paper and to not accept another paper because there were problems also with the runs and with the reproducibility for the results. So here there are the results for the team of which we accepted the runs, and the team is Word Wizard. They used both BM25 and BERT for the standard retrieval part, and then they used the tag example that we proposed as baseline also for the personalized part. Okay, just to conclude, we are planning to offer personalized task also in 2025. But the idea is not to not focus only on information retrieval, but also on other different tasks, such as personalized text classification, for example. And then also we plan to reduce the dimension of the datasets, because we know this was an issue for the participants. And so our aim is to define a dataset that can be used for working on a Colab notebook. And that's all, and thank you for your attention.
Any questions? Okay, so thank you, Marco. It was very wonderful.
Thank you.
Yeah. Any question? Okay, so with this, we are ending long day 2 of the fire. So from tomorrow morning, most probably all the track presentations, keynote. So first, tomorrow we'll start with the information retrieval and information retrieval and in software engineering. We'll start with that and end with the industry talk by Jainam Shah. And after that, we have a steering committee meeting for the invited person, only invited person. You will get a mail. Already received the mail. So at 5:15 p.m. in the conference room. So I will guide you how to go there. Okay. So let's close today. Yeah. So those who are participating in PhD clinic, meet or stay here for a few minutes and meet Srijonidhi. Yeah.